I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, did you hear what I said? It's all about...
Hi, YouTube.
We've got the video pad on, so if you want to get that on, you should sound. Everybody wants to listen. We're going over a debate that we had, but this is part of the Geometry 101 series. This is mainly a triangle one. This is to show how unprepared the people that you're going to end up, well, the people that are running from talking about this issue, and this is going to go over one of the reasons why they are running from. So we haven't. There's no need for us to do an intro, is there? You'll have to bear with us because I'm going.
Welcome to the show, people. Welcome.
Yeah, that's it.
There you go.
I said hi, YouTube.
I would like to ask different buttons in the background, trying to figure out. YouTube is being very strange with live streams at the moment.
Is it? It's the, like I say, they've just opened the new YouTube studio up for live streaming.
Oh,
the classics disappeared.
Bev, what are we going over? The PhD Tony thing? Are we going over some geometry, triangles?
Yep. This is going to be a triangle geometry 101.
PhD Tony thing? Are we going over some geometry?
Explaining the problems that they have with the, well, let's say, I'll call them spherical triangles because they're not triangles. Hopefully we should go through that. There's about an hour of stuff here, but I might be able to cut through most of it. But I'm thinking that there's going to be quite a lot of talk, and so at first we go over a bit that Spurs was in there. So Spurs sort of set them up within the debate, and he said something about he didn't, because I think just earlier on that day we'd had a bit of a chat about geometry and stuff. So he mentioned my name, and then I got in. So the very beginning bit is where PhD Tony's talking about his triangles with Spurs, and then later on I come in and they have to start backtracking. You'll sort of hear what they're talking about. Is everything running all right on the YouTube there, Em?
yeah, fine. Carry on.
Ready to start? Can you hear this then?
I would like to ask a brief question.
Yeah.
Okay.
Do.
Absolutely. Sort that out for
So,
us, yeah.
Can you hear that?
I can't hear shit. I mean, stuff.
You can hear shit, or you can't hear shit.
You might have to come into my live stream to hear it.
Yeah, go for it. Try it again.
So the
Yeah, I can hear it. It's fine.
so let's suppose that I have surveyors.
Pardon?
That was playing through YouTube.
Yeah, good.
Yeah, perfect. Thank you.
As well. This is where he starts with his lectures.
And they set up monuments that are 100 miles apart. I would like to ask a brief question.
Yeah.
Okay.
Do.
Absolutely. Sort that out for us, yeah.
So let's suppose that I have surveyors, and they set up monuments that are 100 miles apart. Okay. And then they go out with theodolites and they set them out in an equilateral triangle. Okay. Well, they set them out and they measure 100 miles on each side between the three. And then they go out with theodolites and they measure the angle from at each monument to the other two monuments. Okay, so we've got 3 angles. What will the angles add up to?
Yeah? Triangle, that's 60, 60, 60, that's 180, yeah?
Okay, would you be surprised to learn
But you
well,
do realise you can't.
that was a good answer, but
sir, you can't have a triangle on a sphere, though, sir.
Right, so already, me and Spurs, we had a little bit of a chat earlier on.
Yep.
And so we have the chat, and I prompted him knowing that they would come up with this equilateral triangle thing. But you hear what PhD Tony there said. Supposing you have surveyors and they go out and they measure this triangle, it's an equilateral triangle, and you go to each of the points and you measure the angle between the other 2 points, right?
Yeah, they're setting it up. They want it to be 90 degrees, 90, 90, 90.
No, 60, 60, 60 is what Spurs came up with, right? Because that is a triangle,
right,
180 degrees. So Spurs completely right, and the way PhD Tony is setting this up here, it's a sighted angle on each of the 3 corners, so it's 3 angles for a triangle. Perfectly reasonable to say that that would be 60 degrees and no more. To which Spurs replies this one.
You can't have a triangle on a sphere, though, sir. You do realise that.
That's exactly right.
Right? Spurs says you can't have a triangle on a sphere, and Tony says
that's exactly right.
That's exactly right. Which it is. Interesting, that, right? Right at the very beginning. So you've got to make note of that. PhD Tony has agreed. It's back in the 300 and 530 days.
So would you be can I yeah, which is exactly right. So when people do this in practice, they don't get 180 degrees.
Okay.
Right? So he's saying that. I don't know where he said that from. Yeah, when people do this in practice, when people measure angles of triangles, they don't get 180 degrees.
Yeah, they've been telling me for years, you know, you go 90, 90, 90 on the ball, and you end up back in the same place. But anyway.
Yeah. Well, we'll get back to that. I've got a model. That'll be out.
Sir, you can't have a triangle on a sphere, though, sir. You do realise that.
That's exactly right. They always get more than 180 degrees. Which is what you would expect on a spheroidal Earth.
Sir, you can't have a triangle on a sphere, though, sir. You do realise that.
That's exactly right. Yes, that's not a triangle, but it is 3 points on Earth's surface. It's a spherical triangle.
What are you trying to say, team?
Oh no!
Yeah, so that's
I was going to let him finish.
What you should do, Craig? My good friend Bev, try thinking, is an expert in this field here when it comes to triangles.
So Spurs calls me an expert.
Well,
eventually I get invited in. These are a few little clips I've cut out here.
Okay. Well, please, but you know, do you see that that's a problem? That every
a few of these are for you. Turn up. I was going to do a turn up cut. What happens with Tony is when he gets frustrated or stuck, he goes into this brain freeze moment where he says a lot. Turn up, you'll love this. I mean, some of this will be classic.
Okay. Well, please, but you know, do you see that that's a problem? That every time that is done in practice, you get an answer of more than 180 degrees. Do you see that that's a problem for the flat Earth?
Every time in practice, more than 180.
Yeah, that's ridiculous.
That is absolutely ridiculous.
No.
You can't know much about triangles or geometry if he's saying that every time you do that in sighted triangles, you get more than 180 degrees.
Yeah, he's got to tell you that up front, so you believe him.
Yeah.
And I can prove that. I can absolutely prove that right now if you give me.
See, Fight the Flat Earth can prove it. He's got some writing on a piece of
second.
paper somewhere.
But if Bev
Yeah,
comes,
I mean,
Bev
Tony
comes
Tony
on,
can handle Bev.
Bev
Bev,
comes on.
the challenge still
yeah.
is.
Only
Yeah,
if
Bev.
he agrees to debate Team about geometry on Team's channel.
And we don't have to leave it at just geometry. We can debate on geometry specific to the shape of the Earth.
There you go. Team wants to
Debate?
debate me on geometry specific to the shape of the Earth. That would
Yes.
be massively brilliant, that one, won't it?
Septic wants you on his channel to debate geometry. Shit, you'll never get a word in.
He won't. Well, you know what's happened right now. They've put the let's not talk to him because of things like this. I think they've realised at the minute they can't handle this geometry stuff.
It's a dangerous subject.
You don't understand. It's not the case that I don't understand what you're saying. The light from an object can refract around a physical obstruction. So you seem to be having a lot of at this stage. I have presented the explanation several times, and we are simply failing to communicate. Are you one of the top 30 intellects on the face of the planet?
That's a good one. Anyone answer? Is anyone? Are you one of the top 30 intellects?
So it's not about me, sir. It really isn't. I don't
No,
profess
are
to be
you?
wise.
Are you? Okay, so there are people who are more intelligent than you out there. I suggest you
God.
find one and get them to explain this to you. Now,
Yeah. There are people who are more intelligent than you. I suggest you go and find them and get them to explain it to you.
Yeah, you're too stupid. These smart people will tell you what's going on. God, I hate that.
Yeah, but he couldn't explain it. He's telling him to go and find
Someone else.
Someone else. I'm not explaining it either because I can't, obviously.
Into one right now, sir.
Sorry? Oh, was that on there?
So I have a PhD. I have also represented my country multiple occasions in mind sports.
Anyone else represented the country in mind sports?
Wow.
I bet that's a fun party.
He's boosting himself up. Yeah. Great.
So when we get to a situation where you're saying you don't understand something and I'm saying you don't understand something, I'm going to conclude on the basis of the evidence available to me that actually you're the person whose understanding is is uncertain.
His position is greater than yours.
Yeah, that is a great one, that, isn't it? You
Mm.
have to remember that one in the debate scene.
Mm.
You start off with that as the opening.
PhD, what's that? Poor, hopeless, deluded.
Right, well, he's gonna show in a bit why his PhD it wasn't in geometry or basic logic.
Oh God.
And I'm going to try and help you out as best I can. But you seem to have this this refusal to accept because you haven't changed your positions. We've been discussing this for the better part of an hour, and you just haven't changed at all. You have not accepted, and this may be I don't know how to explain it, but you're going to have to find somebody you trust, whose authority, whose intellectual authority you respect, on a genuine level, and talk to them about it. Because please believe me, you are wrong, and I don't know how to say it
You are wrong.
Gently.
That's absolutely fine. So I appreciate the time that you've spent, and hopefully we can do this again some other time. Craig, Team Skeptic, it's been a pleasure. Go ahead,
I would
sorry,
like
sir.
to say
same
that
Spurs.
I would like, please You can call me Tony.
Or
Honestly, it feels very unnatural for you to call me sir.
He's doing
Just
it
call me
facetiously.
Tony.
He's doing
But
it facetiously.
yeah,
I think just Tony Spurs is just like that, isn't he? I mean, he may have been overdoing the sir thing, but
only because
Spurs
he
is
knows it winds them up, which it
well,
does.
he's polite though, like that. Spurs, isn't he?
Well, that's
when
the
he's
thing. They
debating.
don't like the politeness. They
Yeah,
want the argument. They want someone to come in there and insult them.
he's a decent guy. He doesn't
Hmm.
berate people like some other people I know.
Yeah, he's not doing it facetiously. So just as Spurs is going, Fight the Flat Earth adds that little dig in just as he's going to muddy the waters. It's a horrible tactic these people use when they're teaming together.
Yeah, well, again, I'd prefer he not do it if it's facetious. But the other point is that you've been very civil, and thank you for the discussion.
Thank you very much. Thank you very much, Tony, as you preferred to before. So, guys, I will catch you all later on. We'll do this again, team.
Bye,
Don't be scared to come hang out on my channel, Spurs.
Will do. Have a good evening.
Team Septic, he was about to say.
Yeah, he's trying to. He wants everybody to go onto his channel. He knows he's Robin now. Fight the Flat Earth's Batman, and Team Septic's now Robin, isn't he? He's the sort of the second fiddle or whatever. He's having to bow down to fight the Flat Earth. It's a bad position to be in, isn't it?
Yeah.
Well done, Spurs. Good job.
Oh wow.
Bev. Why are you running me, Bev? We're supposed to have a conversation fucking weeks ago, man. Come on, what's wrong?
Yeah, sorry for the swearing. Any swearing there. I do get triggered. What are you talking about?
We've started talking about geometry, and then you said something about coming on and discussing geometry on my channel.
No, you might have said something about that.
You said you'd be up for it.
Yeah, you said you'd be up for it. Remember, you don't remember having this conversation?
I said I'd come on if you demonetized, didn't I?
Aye, but why would you ask him to do that?
Well, that was after.
I mean, is he going to do that?
You fucking,
No,
is he going to do that? Hold on.
No, why?
That was after. That was. Hold on. That was after you agreed. You then told Craig in an email that you would come on. Why are you so scared to?
You just told Craig in an email. I've never emailed that man. Ever.
Somebody did.
Not me.
Yeah.
Hold on, but I'm nobody. I don't have a college degree. I'm nobody. Why would you?
I'm nobody either.
Feel more comfortable discussing. I know we're both nobody. So come on, man. Quit trying to act like you're better than me. Let's go.
I'm not trying to act like I'm better than you. Anyway, Tony, you were talking about
Bev. I'm pushing buttons,
earlier,
man. Come on.
With your surveying.
I was talking about. Yes, I was talking about. Well, I was talking about the spherical triangles.
Guys, I gotta run.
Yeah,
hey, hold on,
team. Thanks for
Tony. I legitimately have to leave. So, guys, y'all have a great night. Bev, I'll be looking forward to debating you and crushing you, man. So whenever you're ready,
anytime you demonetize, I'll be ready.
Do that.
Hey, I don't want to hear that shit because Craig has it. Craig has his shit monetized right now, and you're here. So you're making excuses now. Either
listen to this bit.
Either keep making excuses and run, or man the fuck up. I'll talk to you guys later.
You can come over to Emma UK anytime.
Yeah, but we can also stream it on our side.
Yeah, you can. Of course you can. There you go. Invited. They came. They said they can stream it over here, and I said, yeah, of course you can. They can come over anytime. They've always known that. They can come over whenever they want. They choose to run because they're scared of this.
They want to control you in their show. So, they just can't just show up and talk like normal people. They have nothing to say. What is this guy about to say? Something about the spherical triangle again?
Yeah, right. Yo.
Team, thanks for coming on, dude. Right, Bev, this is Tony.
Listen to this for an intro.
Right, Bev, this is Tony. Tony has a PhD. He literally works with gravity and stuff. So he was talking about triangles being greater than 180. Would you like to question him about that?
Yeah. He literally works with gravity
Literally.
and stuff.
Nice. I bet. What a job
Yeah.
title. Literally works with gravity and stuff.
He's got a PhD and he literally works with gravity and stuff. And he was talking about triangles being greater than 180. Would you like to question him?
Yeah. Hey, here's
Damn
Tony.
right.
Here's Tony. He has a PhD. Yeah, I bet he does.
I
Yeah.
forgot how funny this
Cited
was.
triangle.
Works with bullshit and stuff.
Yeah.
Here we go. Triangles from point to point with a theodolite.
Yep. On length scales, large enough. Yes.
Length scales.
Length
Straight
scales.
line
So
from point to
if
point.
Yes, straight line, point to point.
Measuring angles.
Mm-hmm.
Yes, you're measuring. So you let's say you've got points.
Right. So what I'm doing here is I'm just getting him to clarify that we are citing points from point to point, so we can see both of the points.
Right.
As we're working around here. Because the only way you can do that with sighted points is two straight lines, as triangles would dictate straight lines, right? Three straight-sided triangle has two lines dividing the angle.
Right.
Just getting him to confirm.
Points A, B, and C on a surface are widely separated, and you go to point A and you measure the angle. You measure the angle between B and C. Then you go to B, you measure the angle between C and A, etc., etc. When you do that and you add up the observed angles, you get more than 180 degrees. And
how do you work that?
Because, like he just said, you measured them.
Because you've got
you're
measuring the angles and then you add them up.
Should we just measure the angles? Just add them up. It's as easy as that. That easy.
When was this?
Well, I don't. It was like I think was this the
couple of
first
months
time they plotted? They put PhD Tony up, didn't they? They like
Yes.
I've been saying. Was this the first time they ever showed him? Because Chemo went on there, and they sort of looked like that they were trying to jump Chemo with him, and then he invited me on.
Yep.
And we got onto the
Chemo
geometry
made him
thing.
look bad anyway.
Yeah. Chemo had already
that
made
was
him
either
look
the
bad.
first, yeah. I think that was the first time.
Yeah.
So it's been a
'Cause
little while.
Yeah, it's been maybe a couple of months.
Yeah. Okay.
Yeah. Because I initially I thought like they shouldn't really have done this. I mean, Fight the Flat Earth and all of the people there, they're meant to be gatekeepers to stop us from getting to these so-called higher level degree sort of people because they're not ready for the argument.
No.
They're not practiced. And I think Tony here is very green. And I don't know whether they were just like, it was like a star player and they were trying to sort of like win an argument against Chemo.
Yeah, they think they can come up against anybody and win, but they get their ass kicked every time.
Yeah. Well, this is where they show in a PhD as a star prize.
Yeah.
As if we're meant to all be.
They have that confidence though that they're appealing to authority so much that they think they can say whatever they want and they just get away with it. But after a while, it's just going to end.
Yeah. Well,
Yeah,
listen to this. What's coming now? He's already just said like the triangle is a proper triangle, straight sides, and we're just adding the angles up. Simple. And angles like from point to point, that means two straight lines, right?
Yes.
Yes. And
Guys,
three angles would be a triangle with straight sides.
Okay. Yep. And there are two cases. Either we are on a flat surface, in which case it's a simple flat two-dimensional triangle that you are entirely familiar with, or Earth's surface is spheroidal, in which case we're talking about a spherical triangle that obeys spherical trigonometry.
Right. What he doesn't realise here is that he's just talked about a straight line and 3-angle triangle, which is what you call a normal triangle.
Mm-hmm.
There's no way you can do a spheroidal triangle.
Yeah, who says spheroidal anymore?
Yeah.
That's funny.
He's trying to be clever.
Yeah.
But we are measuring point to point.
Yes, we are measuring point to point.
Yeah. Well, that's straight lines then, right?
Well,
come on.
I would be hesitant to.
Yeah,
so
I bet you would be.
you are pointing your theodolite directly from one monument to another monument, but the path that describes is actually curved because we live on a sphere. So
it's curved because we live on a sphere.
You could draw a straight line between any 2 points.
Yeah. And you can
What a
cite
moron.
a straight line between 2 points.
Yep.
So when you say it's a straight line, you're asking, it's the most direct line you can trace on Earth's surface. Yes.
Wow.
But you're citing it from point to point, right?
Yep, you're citing it from point to point.
So you suggesting that the sighting line is a curved line?
I'm suggesting that the path between the two is curved. I'm not suggesting that, well,
He said it.
the sighting line needs to be corrected for refractive effects, which may occur.
But a triangle, like as you've just said, is 3 straight lines. Like, you do understand geometry, right?
Flat.
I would imagine the PhD guy does, yes.
Right. He would imagine that the PhD guy would, yes.
He was hanging his head down right there, looking down.
He needs help.
Yeah.
He's struggling right now. He's saying that the optical sight that you look through through a crosshair that has a vertical line on it, you put that on a point and you move the scope around to end it on another point. Now, the angle is the line from the point to the point.
That's just crazy.
There's no denying that. This man, PhD Tony, has said it curves somehow.
Yeah. A point to point is a curve. God, that is classic.
And don't you need a radius too before you actually measure with a theodolite? I think that's what you were saying, weren't you, Bev, or someone? Maybe it was a different video.
Yeah, you can only have a plot of 1 point anyway. But I mean, that's not what we're doing here. We're just doing an angle measurement from point to a point. You know, it's an angular measurement. You know, in order for you to sight the point on one side, that is your 0 point. So you can consider that one side of your angle, one straight line going from your optical device to that point. And then as you turn, it's just the angle in between the point to the point. And it's 2 straight lines at the ends. No
yeah, you don't get it, Bev. If you use a spherical triangle, it'll all work out, man.
Here we go.
I fail to see why I should dignify that condescending question.
God, dignify it? Oh, this guy's...
He's just been talking about bendy straight lines.
Yeah.
And then I've asked him if he does understand geometry, and he's saying, I don't know why I should answer that.
Yeah.
It's like you should answer it because you don't seem to know what you're talking about, to be honest. Pretty basic stuff, this, isn't it?
Yeah, it is.
I've already explained the distinction between flat Earth and spherical triangles in this discussion. Would you like me to explain it again using shorter words?
Well, if you'd like to, right?
Oh, you're so savage.
Savage.
Okay, so...
Did you hear Fight the Flat Earth there?
Yeah, he's
giggling
trying
in the
to bail him out.
background.
Oh, you're so savage.
Yeah.
He's like, not got a clue. Tony hasn't got a clue. Coming out with an ad hom.
If I have 3 points on the surface of a ball, right, and they form what's called a spherical triangle. The angles, the internal angles of a spherical triangle add up to more than 180 degrees.
And what I'm showing you on screen right now, Bev, is measurements demonstrating that. This is measurements of point to point, like Tony was explaining.
Numbers, they look pretty old, then.
Yeah,
you know anybody that's actually done it that can confirm this, or
it's been done several times.
Yes,
by multiple
Tony,
people.
have you ever done this, Tony?
But Bev, you missed the point.
No, I'm not a surveyor, but I work with surveyors.
You see this column here that says spherical excess. That shows you how much each of these angles was over the 180, and every single one of the triangles were over 180 degrees.
So every single one of the triangle over 180 degrees. Now, poof. Anybody, have you ever tried to draw a triangle from point to point with 3 points and 3 straight lines that has more than 180 degrees?
Yeah, there's no need to go out and do that. You know, FTFE's got the spreadsheet right there. You know, you can just believe what he tells you. Really,
it's geometrically impossible. That's how hard it is. But I mean, he's got it wrote down there on some paper. You can make a triangle with straight lines and more than 180 degrees. Jem Panda says it as well. I mean, it's easy to say, very much harder to actually do it. Just try it. It's a geometric impossibility.
Yeah, their position is so weak.
That's why they're running from this. This is why they cannot take this geometric argument. The straight line kills them. Absolutely destroys them.
Yeah, Nathan, I looked at his show for a minute. He starts off talking about geometry this morning, talking about a tangent away from the sphere. He has a different perspective on the geometry, but he's kind of going that tangent route, saying the tangent line is straight and it kills the sphere. I don't know.
Well, the moment you say tangent, you are giving them a sphere. That's why.
Yeah, that's right.
Just don't use it.
Mm-hmm.
Okay. They were cited triangles, right?
Yes,
absolutely.
Yeah, see, Fight the Flat Earth confirms cited triangles. The only way you can cite a line means it's a straight line. That's it.
Yes, cited triangles. Can I just ask? Can I just pick up on a point that Bev made?
Yeah.
These are old observations, okay? So this is from before the point where the scientific establishment was trying to preserve the fiction of a spherical Earth in your narrative.
Right. I'll play that again. This is what PhD Tony thinks, because these are old. Listen to it again.
So.
Okay. They were cited triangles, right?
Yes,
absolutely. Yes, cited triangles. Can I just ask? Can I just pick up on a point that Bev made?
Yeah.
These are old observations, okay? So this is from before the point where the scientific establishment was trying to preserve the fiction of a spherical Earth in your narrative.
You reckon? From before the point that some scientific establishment were trying to preserve I don't even understand. What do you imagine he's got in his mind there when he's saying that?
I have no clue what he's saying, because he's saying he's citing curved lines on a triangle.
Yeah,
I don't know what.
I think he's trying to say that they come from a time before they were trying to hide it. And because I think he imagines that the flat Earth had never been imagined before very recent times. So he's trying to say that these are historical spherical triangles, like in the past. they could measure triangles with more
That's
than
what it sounds like,
180
yeah.
degrees. I mean, they'd never thought of flat Earth. So in the past, these old people were able to measure triangles of more than 180 degrees. We've lost that skill now, apparently.
Yeah.
This guy's in La La Land.
Yeah.
I never heard anybody dumber than this dude.
It's a PhD.
Yeah, he's bad.
Unbelievable.
He's a smart PhD too.
Yeah, he works with gravity and stuff. Literally works with gravity.
Yeah, he falls down on the job every day.
Every time he speaks.
When did this gigantic conspiracy? When did this gigantic conspiracy be initiated? It's important. You said that's old. Well, there must
triangles
be a conspiracy of some
have 180 degrees internal angles, right?
Spherical triangles don't.
But you know what a triangle is, right? You know what an angle is?
Bev, do you know what a spherical triangle is?
Well, do you know what a triangle is? You have to start that first, right?
Yes, we know what a triangle is.
And three angles.
We know what a triangle is.
And do you know what a spherical triangle is?
Between two straight lines, right?
And do you know what a spherical triangle is?
I've got the definition here. Would that be all right for you?
Yeah,
give you a
spherical
definition.
Triangle.
No, he's just going to give us the definition of a triangle.
No, listen. A plane rectilinear angle is the inclination of two straight lines to one another, which meet together, but are not in the same straight line.
Yes, I'm a bit confused. So let me get this.
So once again, explain to them how an angle is formed or how an angle is measured. Now, think about this, like seriously. You need two straight lines because the angle, the position that the angle is measured at is a division of a circle. That is literally what an angle is. You just divide a circle into so many divisions. You just halve it and halve it, and you'll come up with an angular measurement. Now they've worked on 360, so you are literally dividing a circle up into 360 different segments. All of those segments of a circle would be radius lines. When you see a measuring a protractor or whatever, those lines that come out of it are straight lines. And the angle is the division in between those straight lines in a number form.
Yep.
You cannot have a curved line to divide and give you an angular measurement. It's just not logically possible. Since geometry is a form of logic, like everybody has to try and get in your head right now that there's no measuring an angle to a curved line.
Yeah,
so when they say spherical triangle, that's got curved sides. You literally can't measure an angle to that curve.
Yeah, it's like they're trying to expand the definition of an angle. Remember that guy the
Just
other
like
day?
they did with the tangent. Sorry, Cleary.
Oh no, go ahead, man.
I was just saying this. They do the same thing with the tangent, right? You need a straight line to a curved surface, right? So.
Yeah. Well, yeah. The moment you mention tangent, you're talking about a straight line. Like it's a straight line, but it has to have a curve touching it. So the very use of the word tangent implies the curve there underneath it. Should just stop using the word tangent altogether. Unless you're talking
You have to hear it
geometry.
one time, bro. You have to hear it one time explained to you, and if you don't get it, you are a total waste of breathing air. Like, I mean, that's it.
Look, might start getting interest.
Let me
How
get
can
this straight.
somebody not
yes,
understand? Sorry, go ahead.
No, go on. I was just playing it.
I'm saying how I just can't get it. How can somebody not understand that a tangent needs a straight line to meet a curved surface? How could you not understand that? I'm done.
Yeah.
I'm a bit confused. Let me explain what I do for a living. One of the things I do for a living is now you'd be surprised to know that
that was for you, Turn Up. He was going on about something that he did for his living, but I'll do it again. Turn Up.
We have a non-Euclidean troll in the chat.
Right, nice. Spherical. Has he got spherical triangles? Is he can measure more? Is what I do for a living.
Let me explain what I do for a living. One of the things I do for a living is now you'd be surprised to know that actually involves quite sophisticated mathematical and geometrical understanding. So I'm going to suggest.
I am cutting some of these bits where he talks boring. So I get rid of it.
That perhaps you don't need to be telling me what a planar triangle is.
No, I don't need to be telling him.
No, he's the authority.
Yeah.
That's how they get you with these words.
He can have triangles that have got more than 180 degrees. I mean, he's way better, right? I don't need to tell him that triangles can't have more than 180 degrees. He can imagine them like Fight the Flat Earth. Told him it's possible. Just an angle that was, wasn't it?
Yeah, but I asked you, do you know what a spherical triangle is?
Yeah, well, how you measure an angle is between two straight lines, right?
No. Bev, listen to the question. Do you know what a spherical triangle is?
Yes.
What is
but
it?
It's not got straight sides, has it? Wow. That was his answer.
Well, they just said the sight lines were curved, but now they want to pretend like they're straight. The lines of their
And a spherical triangle is on a triangle drawn on the surface of the two-dimensional surface of a sphere. So there will be no way that you could sight one point from the other point because it's on the surface of a sphere. It's curved. You cannot see the other point because the curve always goes away from you on the surface of the sphere. So don't imagine yourself on the surface of a sphere at any point. It's not needed.
So you're abusing here the term straight. So
I had to add this in a bit here.
Abusing
the term straight. So I've added it in now, just into this next bit, because you will find because what these people would do when they say things, especially like that, you are abusing the term straight. Well, I'm not. A straight line's a straight line. There's no way you can abuse it.
No.
What he's saying is, I'm abusing the term straight, but I want to pass that on to you. I would rather, if I imagine it's you that's doing that, not me.
Exactly. Yeah, exactly.
And you'll hear it in a bit now.
So you're abusing here the term straight. So you're abusing here the term straight.
Abusing straight.
Oh yeah, he does that a lot.
Yes,
this is his whole stick.
So so in multi-dimensional surfaces, so you're abusing here the term straight. Straight corresponds to what's called a geodesic. It's the path of minimum distance joining 2 points on your curved surface. So,
God,
straight is a geodesic on a curved surface. And I'm the one abusing the term straight.
Yeah, he's abusing the term.
He's
You
abusing
said
the
straight
English
was
language.
straight.
Yeah.
He's abusing the English language, I think, this guy.
Oh, it's abusing geometry. You can't, like he's Fight the Flat Earthers told him that straight lines can curve. And most of these people have to have it in their head as a concept anyway. That straight lines are able to do that. They must be able to call straight lines curves, or a little bit of a curve in a certain direction, normally downwards, away from their position.
That's how they get away with it.
Never up or left or right, but again,
preferably at 3 miles.
Yeah.
6 foot height.
Geodesic
You're
surveying.
abusing.
Expo, your audio is a little bit low, man. Wait, maybe I need to turn you up. Sorry.
Got like a bit of an echo.
Can you guys hear me?
So it's
Yeah, Rob, what's
low.
up?
Yeah, just checking. I'm working, but I'm here listening.
Cool, man.
Carry on.
Hear the term straight. But that may not be straight in a different frame of reference.
Anyone, any ideas what the different frame of reference for straight might be?
Ask him, would it be an inertial or a non-inertial frame of reference, and what difference would it make in either one?
To a straight
Unbelievable, unbelievable.
Okay.
So
to measure an angle. Let me do this again.
That was a long pause.
I know. He's waiting for approval. You can hear it in his
be
voice.
Straight in a different frame of reference.
Look at that.
Yeah. I go, okay.
So
to measure an angle.
So
right?
I'm sorry. We're going to move on from angles.
I'm going to get off this subject.
Yeah. You've absolutely creamed me with this one. The minute it's straight lines, I'm stuck.
I would run if I was him from you too, Bev. Believe me.
There's no escape. He's not getting any help from Fight the Flat Earth either.
Nah, you never will.
And we're going to discuss
straight lines, right?
So you're abusing here the term straight. Straight according to the surface that you're on. So you're abusing here the term straight.
Yeah, but you need two straight lines to measure an angle, because it is the bit in between,
on
isn't
the
it?
surface. So you're abusing here the term straight. Straight with respect to the surface that you are on.
Did you see the way he says it? He's like, oh, please, I'm trying to appease you.
It's like he's praying
very
right there.
nice.
Look at him, his hands. It's like he's praying.
So if the surface was a zigzag, it would be straight as related to the zigzag surface, right?
Yeah.
Level is horizontal, but it's not.
Yeah.
So if you're on a curved surface, the line will be curved.
We're just talking about a triangle. Like that's a shape.
And
with three angles, and
yes,
that
it's
is
two-dimensional shape.
Sides.
Yes.
Right.
Because your surface, the surface that you're measuring on, is flat.
Do we want to say something?
Yeah, why is he talking about the surface you're on? The surface you're on. You're talking about angles in a triangle, and he constantly goes back to I'm on a ball. I'm on a ball.
Spherical geometry, right? He wants to get away from Euclidean geometry and has to go to spherical geometry.
Mm-hmm.
Now, spherical geometry is the geometry of the two-dimensional surface of a sphere. That's why he keeps going back to the surface, because that's the only place spherical geometry exists.
Right.
On the surface. There's no vertical component to spherical geometry. No, it's a two-dimensional geometry. So actually, where these people are talking there, they think they're on a flat. They think the geometry that they live on is actually two-dimensional. That surprised you? The people you're arguing with that are calling you flat earthers actually think they're doing geometry of a two-dimensional surface. They actually think they live on a two-dimensional surface of a sphere.
Yeah, because they're absolutely clueless about surveying and elevation. You know, it's just a conceptual ball. They think that from here to there is curved, and from here to there is curved. Everywhere you go is curved. It's just nonsense.
Carry on.
But straight, so you're abusing here the term straight. You know, what is called straight line distance on Earth's surface are actually curved arcs. So you're abusing here the term straight.
Curved arcs?
Oh, so not straight lines then?
So you're abusing here the term straight. They are straight with respect to the Earth's curved surface. They are.
It's like, how can you go from straight to straight on a curve, like a curve straight?
They flip it in their brain. Somehow they go from straight and boom. Somehow it just happens in their brain and they go back to sphere. It's amazing.
Yeah, it's there's curved and there's straight. You know,
it's like a reflex. You know, when you train to fight and to block. You know, when you see a punch coming, your hand goes up. It's like a reflex.
Oh yeah.
The lines of minimum distance. They are the geodesics.
Okay, but you're saying they're on a curved surface, so they would be curved lines, right? I've already been over this with Craig.
They wouldn't be. So you have sorry. What's your highest level of educational?
Go back over that. Saying that. Great.
They wouldn't be. So.
Right, let me get that.
What is your level of education?
That's
again?
a good sound bit right there.
You want to,
that needs to be like an intro.
You want to hear what he actually says. You know what I actually say that makes him have this, because there's a brain freeze here. He just looks up. He can't decide what he's meant to be saying.
Well, he doesn't know.
You're saying they're on a curved surface, so they would be curved lines, right? I've already been over this with Craig.
They wouldn't be. So you have sorry. What's your highest level of educational achievement?
The way he looks at the camera, he might have got a prompt from somebody typing a message to him or something, because he looks at the screen.
What's your level of education? When you like stump them, what's your level of education? Wow.
It's a curved line because it's on a curved surface, right? Was what I said.
Wow.
And how clever are you?
It's comedy. It's comedy.
Why is that relevant?
Because again, we're at the point where
we're just talking about angles, aren't we? On a triangle. It's not really that technical, is it?
Yes, it is, because it's fundamental to understanding how surveying works. So your refusal to understand how spherical trigonometry works is something
well,
of an
surveyors,
impediment.
see, this is where you're going. Like, surveyors use Euclidean geometry, don't they?
They can do, yes.
Okay.
So would you be surprised? So you're a flat earther. What's your reference frame? Where is the origin of your reference frame?
You're a flat earther. He's not a flat earther. Did you call me? Because he's going to say that the Earth has.
I called you a flat earther.
Flat earther.
Because you are. You're arguing that.
Why is he calling you names?
Froze up there, yeah, because
Discord had a glitch.
Yeah. Oh, was that Discord? Because it froze this up as well. Are you all right there?
Yep, it's all back to normal. It just paused everything.
I'll put back to this bit here because he does go. I don't know why he did this. It's as though I got him with that curved surface thing, and he had to go onto this rant.
Because you got him. He's resorting to ad homs, Bev. It's very simple.
They can do, yes.
Okay.
So, would you be surprised? So, you're a flat earther. What's your reference frame? Where?
So you're a flat earther. What's your reference frame? What does he mean by that?
Is it inertial or non-inertial? You should have told him.
What does he actually mean?
I don't know.
I mean, what
First time I've ever heard that.
I think somebody must have prompted him. Send him a, he must be getting hints and tips, and he's not used to seeing all of this stuff on his screen and getting prompts from all of the people he's with. That's the only thing I can imagine, because he's coming up with stuff that just doesn't seem to make any sense.
Bev, you have him baffled, bro. That's what it is. He doesn't know. He's making stuff up as he's going. It's very obvious.
Yeah, he was very green as well. It almost like he'd never debated at all.
Yeah.
He wasn't ready to debate at all.
What's the origin of your reference frame?
He's
You're a
going to
flat
argue
earther.
that he's not a flat earther.
Did you call me?
Because he's going to say that the Earth has.
I
hills and
called you a
valleys.
flat earther.
Oh, I called you a flat earther.
Well, then you are one.
Yeah, what does that mean? Was what I was saying. So what? You can.
Well, I can call you a flat earther again, and it'll be true.
Oh yeah. Why did you do that?
Because Bev, you are a flat earther.
Because you are.
Oh.
You're arguing that the Earth isn't spherical. What shape is it?
I'm arguing that level is horizontal and triangles
Then you're
have
wrong.
180 degree internal angles.
Not on a sphere, they don't.
It's not a triangle, though, is it?
Yes, it is. It's called a spherical triangle.
That's not a triangle.
It's a spherical.
It has 3 angles. It's a
But an
triangle.
angle, you need 2 straight lines. Do you want me to
you
read
don't.
the definition again of an angle?
Well, I can use the limit of the angle between tangents.
Well, you see the way he did that? He did that. Ha ha! I shall pull this Joker card out. I'm going to use tangents.
They're straight lines.
That's
sure.
2 straight
why not?
lines, yeah. Okay. So
Okay,
you're going to use
so there you go.
2 straight lines.
Can I say something real quick?
Yeah.
Where did he get his tangents from?
Well, I just pulled him out of his ass. He's the whole point is though that you need 2 straight lines to make a triangle or an angle, and if you're going to pull out tangents to make those angles, then those tangents will not make a triangle.
That's right.
That's the point. So you can't call it a triangle.
This is donkey dick geometry, right?
This is Fight the Flat Earth geometry. It's completely made up. It's
Yeah.
not even spherical geometry that they're talking about here.
Yeah, he's just trying to patch things together that don't even relate. It's looking rough.
At some point, I'm going to have to get the ball out, right? You just tell me where I think would be the best point for the angle.
And what happens when you add in the third part of the triangle and you measure the internal angles and it comes to more than 180, Bev? What does that imply?
Where did you take the tangent in order to make your...
Answer the question. If you measure the internal angles of the triangle and it comes to more
Craig,
than 180...
where did you put the tangent?
That's irrelevant. I am saying that if you
No, it is.
It's irrelevant. I'm going to make a triangle, but I'm going to use tangents. And then when you do, you've actually got 6 sides rather than 3.
Hey, Ranty was in the chat a minute ago. Is he going live right now?
No, I'm not going live.
He's not. Oh, okay. All right.
Hey, Ranty.
Yeah, what up?
It's very relevant to measure your triangle angles.
So I have 3 points on Earth's surface.
Mm-hmm.
Okay. So I take line of sight at each point. I go to each point and I take a line of sight between that point and the other 2 points, and I measure the angle in between them. Now, the tangent from one point over short distances is going to coincide
it's just
nearly
a straight
exactly
line. Where you go with tangent? Where's the tangent come from?
I don't like that word.
Tangent.
Yeah. We're going to stop people from using the word tangent. He's just cited 2 points from another point and measured the angle and injected the word tangent into it. There's no need for that. He's just done a line, an eyesight line, like an eye level line. No need for the word tangent.
No.
You're just citing a point to another point.
Okay, no. Or
Bev count 3D.
So you have a propensity to ask idiotic questions that are completely irrelevant to the discussion at hand.
That's because I upset him by calling
idiotic questions
his tangent line. Yeah. I made him realize that there wasn't actually a tangent there. He just said it for no apparent reason.
Yeah, what is this guy's PhD in? Gravity? Did he ever say?
Literally works with gravity. That's it. Is there a PhD in that? Literally working
and
with
stuff.
gravity. I think it was something to do with geology, was it, Emma?
Yeah, it was something geology based.
He said he works with surveyors.
Is this the same? Is this the same guy who didn't like my example of a science-based job?
Yes,
and then
he
his
did,
job
he
was
did
exactly.
come here to talk to Tony,
Yeah.
didn't he? Yes,
Of course, yeah.
Yeah, this is that Tony.
And it's great for parties and pubs.
Right, so he does this before. I've heard this from a lot of people. They think what I do with geometry and the real basic straight line stuff, telling them how to do the angles and triangles,
that are completely irrelevant to the discussion at hand. And it's great for parties and pubs, but it just makes you look ridiculous.
Really?
So keep it up. I mean, if you're happy publicly humiliating yourself in front of however many viewers there are now.
Yeah. He's not talking about himself here, Emma. Don't worry. He's definitely talking about me. He's not feeling slightly ridiculous as though he's making a fool out of by not knowing how to do angles.
You ever talk about angles at parties and pubs?
It's a great party trick.
Yeah. That's funny.
The party trick is, right, what's going on is you're making people that imagine that they are very, very clever and they have degrees and stuff and they've got letters after the name. You're making them realize they don't actually know anything. They've seemed to have skipped the basics and they've imagined their intelligence from that point on. They've completely forgot about the basics about straight lines, not bending and things like that.
Mm-hmm.
So it's a great party trick.
Yeah.
Sorry, did I interrupt you, Emma?
No, carry on.
Now, okay, fine. I mean, I can understand why you don't want other people to be paid for it, but it's.
When he said he's not a flat earther, I found out what he meant. Sorry.
Vince, apparently they prefer the word retard.
Hey? Oh, how very quaint.
Like the flat.
Yeah, sorry, we do get those two confused.
Right in the middle of a debate. That's very good. That, like, isn't it? He's the host of a debate.
Yeah, because this guy's going,
Call the guy that is just said that he's not a flat earther. Call all flat earthers retards. Whilst the PhD guy is stumbling over his words and can't work out what a triangle is.
Oh, hang on. Gently's channel says that he holds a PhD in geophysics and a majors in mathematics.
Mathematics?
Mm-hmm.
Wow. I guess he'd know that you can measure triangles with over 180 degrees. It must be advanced mathematics, that.
From a real university, Emma, or online university?
It doesn't say.
No, I don't think Gently will have ever seen it. He must have just heard about it. I don't.
Yeah, go to getyourphd.com. Just click a button. It's pretty easy.
Yeah, he's called PhD Tony, for God's sake. Come on. He must have a PhD, mustn't he? Everyone knows that everybody with it in the name must be that thing. Like Jeff, for instance.
I don't know who you're talking about.
Retard and flat earth, because they mean the same thing.
Yeah. So look, it's yes. Let's start with an experiment. Let's start with an.
No, we have to do that one again. Turn up, this one's for you.
What's your hypothesis?
He does the retard thing, and then Tony goes into a full-on brain freeze, because I don't think Tony's into this sort of the retard thing, like fight the flat earth. And it sort of threw him off it. It's quite funny to listen to, though.
Hey? Oh, how very quaint.
Yeah, sorry, we do get those two confused between retard.
He may have realized
because,
that
they mean
maybe
the same thing.
So
Craig was talking about him.
So look, it's yes. Let's start with an experiment. Let's start with an experiment.
Let's start with the theodolite at point A, and let's sight a line to B.
Yep.
And then measure the angle from B to C.
Yep. And they add up to more than 180 degrees.
Again, they always add up to more than 180. Don't you know that? Triangles.
Still, always.
Brilliant. Okay. But you say you're not a surveyor.
Not personally, no.
Okay. Okay.
But I work with surveyors. I work with people with surveying expertise.
Any chance you could get any of them on here for a chat?
I've
got a really cool water level test.
Yeah, you do. It's fucking hilarious.
I have seen that water level test, and I have to say that I think you should seriously consider whether or not you're actually qualified to design meaningful experiments.
Oh my God!
A horizontal line and a water level. He is calling an experiment. And he's questioning my ability to be able to do this.
Was that another ad hom?
I think so.
The whole thing's an ad hom after like 5 minutes.
I don't believe Bev insulted him once yet.
There's no need to. I mean, he's doing it all to himself, isn't he?
Yep. Just saying.
A water level test. Seriously.
Oh my God.
Yeah.
I've deleted the picture.
Allow me to so a fluid of any sort.
There's another bit for you there, Turner. all of them together.
Adopts a geometry in response to the forces that are applied to it, right?
Fair enough. I think
Okay.
you're going to say normal.
So,
What's the force?
Yeah. Yeah, he's after talking about it now, and I'm leading him to. There's another brain freeze here because he keeps going through. So I go normal, geometric term for the force that they're going to go through, and he's going to talk. He doesn't really know what he's talking about. This is quite a good one. This.
Are you leading him
I'm
down
not
a
going to
path
say
of
normal
destruction?
because you.
Yeah, they're going on to the. I mean, like, because this sort of level / horizontal has a bigger connotations to it because the gravity comes into play, and this is the part that they definitely don't want to go down. This is where the water level takes down this particular path where you start linking the G, and he's doing it now mentally as he's talking, and he doesn't really want to go there. So he's flirting around it. It's funny.
You may have wind, you may have resistance forces from the container it's in, you may pour the water
Can we say
out.
perpendicular then?
No, we're not going to say perpendicular. We're going to say that liquids adopt a geometry in response to the forces applied to them.
Equilibrium.
Because forces...
What the hell, man?
So I've used normal, perpendicular, and equilibrium. Then 3 words in this section, right? Listen to his brain freeze.
Why do they have a problem with perpendicular? I mean, it's ridiculous.
Two straight lines.
Yeah.
They need one of them to be curved.
It's funny because Bev is so subtle, right? The way his style is that catches them off guard. That's why he's baffled. He doesn't know what to say.
Yeah, listen to this one where as soon as I say equilibrium.
Geometry in response to the forces applied to them.
Equilibrium.
Because forces... I'm not sure... yes. What? Sorry. You just threw in a random word there. What do you mean by equilibrium? What are you trying to clarify?
What do you do to him?
It's like
a random word. One word, bro, and you knock them out like with one punch. Bang.
No save from Fight the Flat Earth or anything. Nothing. Just leaving him. He's out there
Ambulance.
on his own.
Never mind Fight the Flat Earth. Ambulance.
Water in a tube, the 2 ends will reach a level or an equilibrium, right?
Yeah.
Yeah. Well, that's what a water level is, right?
Okay, so define level.
Horizontal.
Wrong.
No, I reject that characterization.
I just reject it. No, I reject
Level is not horizontal.
that. Here comes the best one now. Here we go.
Do you?
Yeah, he's got to be right too because it is very wrong.
Level is a straight line on a horizontal plane. How's that?
That's wrong too. Okay, so define level.
Horizontal.
Wrong.
No, I reject that characterization.
Do you?
Yeah, he's got to be right too because it's very wrong.
Level is a straight line on a horizontal plane. How's that?
That's wrong too.
I mean, that one phrase is got them.
Oh, that's so
can't
funny.
have it being true.
You almost had it that second time. No, it was close. That was close.
It was like a game show right there for a second. What is level? You said horizontal.
You guys remember Gilligan?
Oh, I'm sorry. That's not correct. We were looking for what is perpendicular to the force of gravity.
Yeah.
Perpendicular to the force of gravity.
That's right.
Well, sorry, you can assert that. You can assert that, but we won't obey that.
Well,
water won't obey that.
Water level is a tool for establishing a horizontal plane of reference, right?
Over short distances, and with a non-zero error.
What's a non-zero error? What does that mean?
I have no clue.
Pull that was ass.
Yeah.
No, I don't know either.
He's made up a lot of terms today. This man.
It's not perfect. I would say it's going to be it's not perfect. So your error, we don't know what it is, but we know there's error there. That's
Just like
basically
Al
what-
Baruni's measurement. It's a little bit off.
Isn't that a stupid thing to say? And it's not something. You can't define what something is by saying what it's not. If I gave you a fruit and I said it's not a watermelon, you would be like, okay, what is it? I'd be like, well, it's not a watermelon.
Well, there's non-Euclidean.
Yeah, that's the geometry they work. It's definitely not Euclidean.
No, something else. Yeah. We don't know what the hell it is, but it's not that.
It's definitely not Euclidean.
Oh, so what sort of a short distance would you say? What's the maximum length you can put on a water level, in your opinion?
Well, that's the other problem is that zero error or non-zero error. You need something to know what is zero. That's the only way. And this is what he's having a trouble. He's saying your horizontal deviates from horizontal. Like, well, how do you know it's deviating from horizontal if you don't have a horizontal?
Oh,
what is he talking about?
Yeah, that's great. Yeah, good point.
Yeah, I've been dealing with that for quite a while. It's like if you measure a deviance from vertical / horizontal, what are you measuring that deviance from? Because vertical will always be perpendicular to horizontal, so there's always going to be a 90-degree between them two. So
This is how you know their model. It's their. This is what they're showing. This doesn't work with my model. No, reality is not matching with my model. I have to do something.
Yeah, that's right.
That's one of the models, right?
South is down, is it?
Yeah, apparently.
Gravity just acts towards the bottom of the page, and that.
Oh my god.
It is. You seem to have difficulty. So imagine.
Is that him talking like that, or are you doing something?
Yeah. No, that's him. Like his brain's gone. He freezes.
He's baffled.
Seriously,
I thought that was like edited,
No.
man.
No,
God.
that was all.
These guys are not used to being asked questions. They're just used to monologuing what was monologued to them and passing the chain along. They don't know how to answer a hard question.
It's not a hard question. We're talking about a triangle, right, with 3 straight sides and 3
If he's
angles.
really a PhD.
No, he can't get one line straight. You want him to get 3 and connect them? Come on, Beth.
So imagine I've got a tube that, as drawn here, it goes down, it goes across, and it goes up. Okay, so a difference in air pressure between 2 places on Earth's surface will result in a difference in the height in the tubes. Right?
It establishes a horizontal plane of reference. The 2 ends will find an
No,
equilibrium, right?
But not necessarily the same height, because there could be different air pressure at both heights.
Right, so it would be air pressure changing the height of the water level from horizontal. According to PhD Tony. He's getting confused again, right?
That's another first.
Well, it's meant to be the curvature of the Earth on his model, but he just took it back to air pressure. I don't know. I haven't got a clue.
Yeah, that's the cause of Earth curvature is air pressure, I guess.
Yeah.
First time I hear that, like the first time I hear spherical triangle. Have you guys ever heard that before?
Yeah, they're talking spherical triangles.
Bro, they curve air. Okay,
Yeah.
like they'll take a thing of air, like, and curve it. I don't know how you curve air, but they do it.
And I don't know about air pressure, but the difference in, like about a foot off the ground, over a mile. I don't know what the sort of air pressure difference is going to be. Do you reckon you could get 8 inches over a mile difference air pressure? But
yeah.
Obviously, it would have to change from depending where you're stood, at which end of the water level. The air pressure would have to change at the other end if you walked.
Yeah, that's why you have gravity. It does things like that.
No, you leave the tubes open, right?
Yes, and there will be the air pressure varies as a function of position. You are aware of that.
Okay. So how far apart do you reckon would be the maximum distance you would say for a water level to maintain a horizontal frame of reference?
To maintain a horizontal frame of reference, to what precision?
As well, I don't know. As a scientist,
to what precision?
So what sort of precision would you want if you were measuring a water level?
Well, it'd be level,
What sort of precision? Right? He's asking me what precision, and it's like he's the PhD guy. I mean, what sort of precision do you want to talk about?
Is it not either level or not level? You can't have a little bit level.
Yeah,
it's like being pregnant. You can't. You either are or you're not. You can't be a little bit.
Spot on, level-ish. Yep.
Well, it's all coming back to the standard. You got to have a standard to have deviation. They deviate their standard, so they can't have a standard.
Mm-hmm.
Yeah.
So the precision to be able to measure curvature, presupposed curvature.
To the precision I'd suggest you'd need.
Right, he's just about to pull a good one out of his ass here. Anyone not seen it? Have a guess how far PhD Tony reckons you'd have to go to get the precision to be able to measure whether there's a curvature in a water level.
Singular
Quarter
point.
mile.
2 inches.
That sounds very scientific. That I think you get shocked.
What, 20 kilometers?
What?
He forgot the 3 miles. Wow.
Great God.
That's like 10 miles.
Wow.
Yeah, it's like
kilometers to what?
4 miles.
PhD.
Yeah, PhD Tony couldn't tell if it was curving. He'd have to go 10 miles to be able to tell.
Wow.
So what happens to that boat that disappears at 3 miles?
I think he just pulled that out of his ass, really. He was
Bev,
struggling.
Everything
you
baffled him, bro. Everything, he's just pulling it out of his, you know what? Everything he's saying from here on in.
Did he disappear after this, or is he still around somewhere?
Oh no, he's still around. Yeah.
Jesus, man. Ooh.
This was his first showing.
Mm.
He destroyed me.
Notice any deviation from horizontal?
Before you get effects that are, before you'd be able to detect the difference between the two hypotheses, yeah.
But
And you'd have to correct for.
All there would be a 12.4 mile distance with a hump in the middle, right? On the globe.
Well, you've got to imagine that when I'm doing this, right, I'm already saying to him, there's a presupposed curvature or a drop of the water level as opposed to horizontal. I think this must have been before Jesse said to me on Jose's that it is a definite measurable drop away. The water level drops away from horizontal and it is measurable. Definitely measurable was Jesse's. That this must have been before that point. So I'm already establishing, right, well, there's a horizontal and you go in 20 kilometers before you think you can notice a deviance
with precision
from the horizontal.
Wow.
And I'm thinking, yeah, how big on earth do you think you live on? And that's at this point, that's what's going through my head. Now, I think that sort of thing is also going through his head. And now he's realizing, no, I think there's that curvature doesn't seem right. And he starts to have to pull it back again.
And you'd have to correct for a variety of effects. You'd have to correct for differential.
Sorry, somebody there.
I was gonna say, right before you start that clip is where you need to insert that little clip of the commentator that goes, "It was at this point that he knew he done fucked up."
There's plenty of bits like that.
That's funny.
The two hypotheses. The really good one is half an hour off yet.
Oh wow!
Complete failure.
You'd have to.
Wait.
Yes, we have two hypotheses. One hypothesis is that the Earth is a sphere, and the other hypothesis is that the Earth is flat.
Right. These I'll have to question this one. Right. Two hypotheses. Right. You don't. When you go out and survey, you survey the land, record it, document it, do that. That's it. Make a map. Do whatever you want to do with it. You do not have two hypotheses of what you're doing when you go out.
Yeah. If we have a half hour in our time, the way we stop stuff, you're looking at a long time there. You know what I mean?
Or largely flat.
But 20
so
kilometers, there's a fair bit of difference, right? Like, isn't there meant to be a difference over 1 mile or like half a mile? Quarter of a mile, I've heard people say that they can measure it. Some of the surveyors, I mean, I don't know if any of your friends have mentioned anything like that. But I mean, I've heard surveyors say that they can measure it in quarter of a mile.
They're doing something very different than water level.
Well, one's a horizontal plane and the other one's got a curvature to it. So over 20 kilometers, I would imagine that's a fair bit of curvature on one model. And the straight line that horizontal would give wouldn't have any curvature to it at all. So why do you think it would take 20 kilometers for you to be able to tell a difference? Surely there should be a difference over 1 mile, right?
So, not necessarily instrumentally detectable. Using a water level experiment. Using a water level experiment
isn't any good. Over a mile.
There are
He's trying to listen to him.
Yeah, you can hear tapping going away, and now I can guarantee you that's not me. I don't tap like that.
They're trying to back him out of that. Oh shit! No, just say it was a water level you were talking about. You know, listen to me. And he's trying to listen to you, and he's trying to listen to that other person all at the same time.
Yeah, I think so. And you can hear tapping going away. So somebody's typing something now for him to change the subject or do something. Is probably about to happen now. A change.
He's probably going to throw something smaller scale.
Abort.
Yeah.
Oh no, he doesn't abort yet. He just keeps digging, but it's just a quick change.
So, wind effects.
You realise how drainage works, right? Water flows downhill, right?
I'm going to ask you.
Wind. The water's in a tube. Like, with a little opening on the top. Come on, man.
What about a canal?
It is. It's great.
Mean surface conditions on a. So you asked me the question. I gave you an answer. You ask other people a question, they'll give you a different answer.
Yeah.
You need to do the experiment. If you want to convince me, you're going to need to do the experiment over the conditions that I say.
Over 20
Not
kilometers.
over what other people say. Yes.
Look, he's like, you've got to do it like I say, 20k or no go. I'm not going to believe you if you do not do as I say.
Nah. You can't play with me.
Wow, this guy's great.
And if you can't do it, then
you can't. You seriously think you can't tell over a distance of 20 kilometers whether it's straight or curved?
I'm saying you can very easily
Over
tell
20
over that sort of
kilometers.
distance.
Oh, right.
Yes.
Well, so why?
Yeah, I can do it. Yes, of course you can. Like, well, why are you telling me I have to do a 20k water level then?
Are you saying that you think I should have to go 20 kilometers?
Because what you're
In
trying
fact,
to
there is a canal here down the road that leads to Liverpool Canal, goes 27 miles between locks.
Yep.
Yeah. Well, is that not
Yeah.
level?
So there you go.
Of course it is. Water is always level.
Of course it is. But that doesn't
So that
make
curves, does it, or is it horizontal?
Yes.
It curves as level.
Oh, it curves.
Yeah.
Okay. So we should be able to measure then with a level,
not with a
like
water
a
level,
theodolite level.
With a
not with a level.
Is that horizontal?
Yeah, with a theodolite, yes, but not with.
Right. So this is where we go. Initially, the whole water level thing was a water level test, right? Just water level. But that in turn, they didn't anticipate that we would go and have other checks with the other tools that we have for establishing level.
Mm-hmm.
So this is where they come in now with the now you can measure with a theodolite, definitely, yes.
Water level thing that you are suggesting.
So you
yeah.
right, okay? So you think a water
Theodolites
level
will work.
Level,
No,
but a level
Man, somebody
is
changed
level.
his tune for him.
Yeah, he's come back now.
Mm-hmm.
He thinks he's got the upper hand, but
like Tony was saying, you have to take a lot of things into account for the water level, like atmospheric changes, minute disturbances.
Fight the flat Earth to the thing. He's been sat researching a little bit, and he's got a bit of confidence.
There could have been an earthquake.
The water and
could have
everything.
affected it. An earthquake.
He's trying to buy some time right now.
Yeah.
Just talking shite.
It's going to be very hard to see. Let's say 27 miles. Did you say it was? Yeah.
Yeah, in between locks.
All right, so that's about a third. So about a third of a degree.
So it's about 15 miles as the crow flies.
So over that 27 miles, you should expect to see a third of a degree deviation.
How many feet in drop?
He's jigging about.
Do you reckon?
Drop from where?
Well, drop from the horizontal, because that's what
right. So
your man's just said here.
A drop
and
from
you as well.
A drop
No,
from the point
I never
where
said anything of the sort.
Yeah, you did one curves and one straight.
Yeah. So when you say
right, so
drop,
the straight one goes straight, and the curved one must drop away from the straight bit, right?
Yeah, he doesn't like drop. A lot of these ballers don't like the idea of you using the word drop. That's because they know there is none. It's horizontal. It doesn't drop at all. You have to imagine the horizontal is a curved path with no drop. PhD Tony's going to get stuck.
Right,
I'm not going to talk about drop.
Well, what's it doing in relation to the horizontal?
Well, first of all, it rise up
diverging.
To it from your eyesight.
Oh,
it's diverging. Like that.
Over in Ranty's general chat right now, WS is battling Dodo, talking about parallel and horizontal.
Oh, wow.
Interesting.
Ooh.
Yeah, Ranty's over there too.
Just in the chat, or
yeah. Mm-hmm. It's the big conversation piece now.
Yeah, I would imagine so. The parallel's a bit of a step up from the triangles. We'll do the triangles first, and then we can step it up to the parallel geometry 101 next time, perhaps.
Okay, diverging in any particular direction?
Away.
Away. Like upwards? To the left?
Define up.
To the right?
Define up.
Like when you stood there.
What the hell?
Yeah. This is quite good.
Yeah,
I was impressed with
yours.
off
Yeah.
the top of my head. This.
Right? And you're looking out on the horizontal.
What's your eye height?
Up is like towards the sky.
Yeah, Bev, what's your eye height for this 20?
Were your eyebrows pointing up or down?
Yeah. I was actually pointing when I said that. He couldn't see me doing it, of course. Right, define up.
7 miles.
What do you mean? Eye height. It's the water level in the canal.
Fight the Flat Earth's trying to save him again now by just telling me about an eye height on the water or whatever. He's buying time because he knows PhD Tony's struggling.
Right. So are you saying
he's reading something when he looks
drop,
down
so
right there.
Are
he
you
looks
saying
down
the
and
drop
he's
from
reading the
right at the
text or something.
surface?
Well,
He's
yeah.
not
Where
looking at
are you
the
going to stand?
Yeah.
On the canal to find a drop. Let's say we'll stand at one end of it, right?
Yeah, but
This is why this drop thing is so idiotic, and it only reinforces the mental misconception he has about the nature of the Earth.
There's another one right there.
Yeah. It's because the drop thing. He gets really upset about the idea of there being a drop because he knows there is none. The only way you can't have a drop is with it being horizontal.
Yeah, he said it was less than 20 kilometers. I think he's a flat earther and he doesn't even know it.
Yeah, they get into these conversations, and I think that's what when the penny drops at certain points, and then they hate themselves because they know that they can't say it. They can't say it to fight the flat Earth. Oh yeah, right. Sorry, fight. I've got this one wrong. Bev's actually correct here.
Yeah.
It only reinforces
and what's curved.
It only reinforces the misconception that south is down, or
science.
The south is down, right?
That sounds like some Jim Panda shit right there.
A good one that started the developing of the north, south, east, west one, right? That sort of idea. When these people say things like that, you know that's a problem that they have.
They do, yeah.
A straight line and a curve.
Bev, let me make it more simple for you.
That's meaningless.
You're 6 foot,
What?
right? Let's say you're approximately 6 foot. So
Damn,
your
Bev,
eye
you're
height
6 foot?
that you are looking at.
Yeah, he's giving me a few inches.
Your eyes are even 6 foot, I guess.
Yeah, he's got.
You're about 6'4".
Being generous.
Out at is 6 foot.
No,
Right.
I've got a short step ladder.
we're on the surface of the canal, Craig.
Okay, so
we're trying to find
so
out
your eye height
how
is
much
0.
difference there is
Zero.
from a horizontal to the water level
Yes,
that
but-
you say is different.
Yes, but how
I say
high
it's the
is
same
your,
thing.
How high is your viewing of how high above the surface?
We're
of the
on the
water are you
water.
looking at?
We're in a canoe on the water.
0 feet is what you're saying, right?
Yeah.
Stalling for time, right? All of this stuff for Fight the Flat Earth.
Yeah.
doing
Yeah.
calculations and stuff.
Okay.
So the reason I object to this is because down changes direction as you move. Okay,
Interesting, right?
and so what you're actually referring to is the distance between a tangent at the point of observation extended outwards and the surface of the Earth at a different point. But by calling that drop, what you're asserting is that the force of gravity, or downwards, acts in the same direction uniformly along that path, and it doesn't.
Perpendicular.
Yeah,
Does he not realize that he lives on a ball? What's he talking about?
He's just confusing himself now. He's talking about things. He's struggling big time.
Right? Is it not work? Is it not a force normal? Is it not?
Normal to what?
Well, I don't know. What do you think normal is? It's perpendicular, isn't it? I mean, that's just another word for perpendicular.
So perpendicular.
Right, now this is another bit that you should pay particular attention to, because this is the perpendicular bomb when you link it to the G. If once you replace G for vertical, perpendicular becomes a problem. Tony's just about to find that out right now.
Perpendicular refers to two objects. Something is perpendicular to something else.
Yeah, if one of
we're
them's
talking
vertical,
about the force of gravity. We're talking about the force of gravity.
What's his face when I say one of them's vertical?
So perpendicular refers to two objects. Something is perpendicular to something else.
Yeah, if one of
we're
them's
talking
vertical,
about the force of gravity. We're talking about the
force of gravity is vertical, then the other one is horizontal, right?
Oh, he didn't know what to say now.
No, we told you this.
No. Is the force of gravity not vertical? I think it is.
Before, Bev, horizontal is relative.
It's perpendicular to vertical, right?
Yeah, but it's also relative to position. Your horizontal right now is different to mine because we're separated by approximately 700 miles. So my vertical, exactly straight up, is very different to what yours is. But for both of us, they are still vertical.
Great God!
That's what you
Oh
think.
my goodness!
Right?
No, that's absolutely been demonstrated to be fact.
That's it. I've just reminded him that gravity is vertical, and he's been playing for perpendicular, which makes that horizontal.
Wow, that's amazing.
He looks like he's really suffering there.
He looks like he just remembered how much he paid for that PhD.
1995.
One of the reasons that I brought up
Tell him what he's won, Bob.
education level is that one of the things that we're taught to do is
listen to this. Right, I did this twice. He's just done this head thing. This is how he comes out of it.
So one of the reasons that I brought up education level is that one of the things that we're taught to do as undergraduates is be very precise in the way we phrase things and understand complicated physical models. And you're insisting that your flat Earth geometry will work in every circumstance.
What are you talking about?
So
it's Euclidean geometry, dude. It's not flat Earth geometry.
Yeah, did you catch that?
Mm-hmm.
What did he say? Business models.
He said when it will go over it again because I had to clip that because it's one of them ones you have to listen to again. You want to rewind. He says one of the things he was taught to do in undergrad is to be very precise with his
understanding of complicated models.
Words and the phrasing of the way they say things. And I'm using flat Earth geometry. So that's nice of him to admit that Euclidean geometry supports a model that he doesn't like.
Yeah.
Listen to it again.
So one of the reasons that I brought up education level is that one of the things that we're taught to do as undergraduates is be very precise in the way we phrase things and understand complicated physical models. And you're insisting that your flat Earth geometry will work in every circumstance.
What are you talking about?
That's a great soundbite right there, man.
This is
flat Earth geometry. That's unbelievable when he said that.
That guy is not a PhD.
Pretty bad robot there.
That guy's not a PhD. Yeah, I heard that guy is not a PhD.
Hey,
he's still going.
A PhD talks like that. No way.
Yeah.
Well, I don't know. He might have been talking with Fight the Flat Earth. You know, like when you get in with people and you start talking, you know, once you've been around them for long enough. I mean, it's quite possible that this PhD Tony has been buttering up Fight the Flat Earth and all of them for quite a while in the background, and you know he's come to the forefront now, and I mean he's told them he's got a PhD. In fact, the Flat Earth has told us that he's got all sorts of qualifications and submarine. I mean, he's calculated diesel, how much diesel you use in a submarine, and all of that sort of stuff. I mean, like, you're not suggesting anyone would lie about things like that on YouTube as well.
Don't forget he died as well, Bev.
Oh, he died. Yeah.
What I am suggesting is that anyone that has a high enough IQ to get a PhD has a thought processing speed quick enough not to use the word every word.
You must be a PhD, Rukia.
Yeah, you sound like a proper PhD.
I think I could be, but I just don't have the time.
Oh, it's Euclidean geometry, dude. It's not flat Earth geometry.
So, Euclidean geometry.
I'm here.
So,
yeah. So, and at this point, this is where Skeptic comes back. He's obviously he said he'd disappeared and he had to go, but he must hear the and the brain freezes of Tony and think, "Here I come. This is my bit now, and I'm coming to help out." So here's Team Skeptic. He's got his cape on and everything. He's coming to help out.
But
yeah,
can I ask a question? Because I actually for my last video I had to do a lot of this research
Here
and I
he
actually
comes to
consulted
wreck the
with
day.
Jesse Kozlowski about.
Right, so he's had to do a lot of research and had to have a word with somebody. Have a listen again.
Euclidean geometry.
I'm here. But
yeah,
can I ask a question? Because I actually for my last video I had to do a lot of this research and I actually consulted with Jesse Kozlowski about some of these measurements.
But I thought he was doing research, not talking to an idiot.
He was talking to Jesse Kozlowski. I mean, Jesse Kozlowski's the man. It might have been after this, actually, that they were talking, that Jesse decided that it would be wise of him to say that it was definitely measurable, the drop of the water level from horizon.
Yeah, he came in to bail this guy out.
Yeah.
Bev, on a flat Earth, if you take two theodolites and you line them up and you align them visually with each.
Have you read this one before? Like you like this one? Jeff,
yeah.
He's been talking. He says he's been talking to Jesse Kozlowski, but this sounds like Jeff's.
Each other. Then if the Earth is flat, then you should get a combination, a sum of zenith angles that will equal 180 degrees exactly every single time. If the Earth is concave, okay, meaning that it goes up like concave to it directly overhead. So if you have a 90-degree zenith angle, then essentially you are looking above 100.
It's boring.
You are very trying. You say vertical.
A three-dimensional spherical object.
Okay, so you're saying that vertical and horizontal aren't always perpendicular?
No, what he's saying is that vertical. So
go on.
So this is what I was saying. When you say vertical, mean
team was just talking for Jesse
pointing,
Kozlowski. Now you
you mean pointing. So
you have to do it again.
Oh, what a sigh that was.
like,
Poor guy.
I don't know whether that was because I pointed out that Septic had been talking about Jesse Kozlowski, or just sort of he realised he shouldn't actually be there.
Particular.
Sounds to me like
only.
Oh, sorry about that.
No, go on. I was just going to.
Sounds to me like a high pressure leaving into a lower pressure, or lower pressure into a higher pressure.
Saying is that vertical. So
go on.
So this is what I was saying. When you say vertical, mean
team was just talking for Jesse
pointing,
Kozlowski. Now you
mean pointing. So you are very trying.
That's special. That's special, man. That's a sound clip right there.
Poor guy.
Yes.
The vertical mean.
DP said he wanted to do this and just take the ums out of it and see how long you could get of a
It would sound like that choir, right?
Yeah.
Means in the opposite direction in which things fall.
Right. Oh, that was a good one. Yeah. Let's listen to this. What he says.
You are very trying.
Yes, he is.
The vertical means in the opposite direction in which things fall.
Do you get that?
Yeah.
Gravity, of course. Their number one go-to.
No,
they don't want to say it. Vertical of which things fall. Opposite.
Yeah, it said the opposite of the way things in which things fall.
Would that be the same line? Up and down, vertical?
Yeah.
How stupid is that?
I'm still laughing at the PhD sigh.
That sigh is going down in history.
There's no way a flat earther, so-called, a horizontal man should be able to make a PhD sigh like that.
Bev is a wrecking ball.
It's not. It's just geometry, man. Basic, simple geometry. That's all we're talking about. We've not even really got off straight lines and angles yet.
They hate the truth, man. They don't like the truth and logic of geometry. It kills them. It wrecks their world, right? Their worldview goes down the drain. That's why they put their face in their palm.
Yeah, vertical is perpendicular to horizontal. They don't like that at all.
No, straight lines. They hate him. Is there a fear of a straight line? Because that'd be great. If there is, we might have to develop that.
It's a great circle. You hear Bob? You ever hear Bob talk about great circles when he talks about flights?
Yeah.
Oh my god. Oh my god.
Straightenophobia.
Yeah.
Since things fall in different direction.
Here we go.
Yes, vertical means up.
Anyone heard of that before?
Vertical means up. That's so
but he just asked you before what was up. Remember when he asked you?
Yeah.
Define up.
Yeah.
Well, it's a lesson.
Right.
No.
Objects fall.
No.
No.
Down.
It's just a line in a position. It doesn't mean.
There's no way this guy's a PhD.
He's getting schooled on vertical. Now watch this. This is a line. Listen how easy this is.
Up or down. It just means vertical. It's like horizontal doesn't mean left or right.
You know that like horizontal, plumb, and vertical, they're not Euclidean.
You want to hear that again? Look, he says vertical, it means up. And then listen to the schooling, how easy this
vertical means up.
Right?
No. Objects fall
down.
down.
No. It's just a line in a position. It doesn't mean up or down. It just means vertical.
God,
it's like horizontal doesn't mean left or right.
Almost a vector.
You know that like horizontal, plumb, and vertical, they're not Euclidean.
So when you say the perpendicular, yeah, that's
right. So that big freeze to which Fight the Flat Earth says, they're not Euclidean. It's another genius bit. This, I mean, they're struggling. Tony here is proper struggling because he's just said vertical means up. That's retarded, right? Nobody means that. It can't mean up, can it? Vertical's just a straight line.
Up is a direction.
You know that like
I would say vertical means up and down.
Vertical has no.
Yeah, it's just a straight line.
Magnitude.
It means both. It's a line.
Yeah. You need direction for magnitude for up, right? A point or something static won't be up or down. It would just be a line, right? A line that is left to right is a horizontal. It's not moving. It's not a direction. It's just a line in a configuration towards the Earth. If it's up and down, it's a vertical. That's not motion or a direction. This guy's, yeah. Hey.
Right, so here we go. Fight the Flat Earth says.
You know that like horizontal, plumb, and vertical, they're not Euclidean.
So when you say the perpendicular, yeah, that's Euclidean.
So so
I think Fight the Flat Earth even goes oof, as though he's just been winded by that one. Because they're not Euclidean, and I go, well, when you say perpendicular, yeah, that's Euclidean.
Yeah.
Listen, here we go again. He says it pretty quietly.
You know that like horizontal, plumb, and vertical, they're not Euclidean.
So when you say the perpendicular, yeah, that's Euclidean.
So
yeah.
He goes,
yeah, listen, Tony.
Well, he paused there too. They're not. He said,
you are essentially too ignorant to use the term Euclidean.
Yeah, you're too stupid, Bev.
You gotta be kidding me.
He's like a little child.
Imagine being told you're too stupid by some guy who's said 1 out of every 6 words.
Bev just got done educating the whole online community on Euclidean geometry, and he's calling him dumb. Wow, that is freaking special.
It's not finished yet, and the pylon begins now, right? Because Fight the Flat Earth, Fight the Flat Earth does the little, well done, Tony, you're very great, and then that automatically gets everybody. It's like pile on now.
I think that's my new favorite soundbite.
Oh.
You're too dumb to use the word Euclidean. God,
it's not finished. It's not finished. The team does a little better one.
Like understandably.
I think you find it to be a very clever term to use in daily talk, but I don't think you completely understand why it's clever and what exactly it means.
You don't understand, same old shit.
Nor how to use it.
You said something smart, but it was an accident because you're stupid.
Yeah, you don't know how clever it is, and you don't know how to use that word cleverly. Here we go.
Exactly it means. Nor how to use it cleverly.
Nor how to use it cleverly. You don't use it cleverly. You just use the words of Euclidean geometry. It's a logical structure. There's no need for you to use it cleverly. You just state the facts. And they prove themselves. This stuff isn't as difficult as what it seems. We're talking basic geometry and basic triangles and angles here, and these people. I mean, that was perpendicular. That put them in a brain freeze, and the best he can do is, you're too ignorant to use the word. It's shocking.
Or why I've got a book on my desk that says when straight line becomes curves, non-Euclidean geometry.
Well, if you do it, do you have a definition of
Will you share my screen, please?
Yeah, 2 seconds.
Will you share my screen, please?
There we go. You're live.
Perpendicular is another word
Okay,
for
so
orthogonal.
this right here.
It's where. Yep.
Go ahead,
sorry.
Tony. I'll let you finish that before I start.
So perpendicular refers to orthogonal. It's when two
Orthogonal's X, Y, Z coordinates. Just means right angles to each other. I mean, everybody knows what it means. Perpendicular, right angles, orthogonal. Just another word for the same thing.
two vectors have an inner product of 0.
Yeah, sounds clever, but
so a vector in any one
don't try
surface.
to use that cleverly, Bev. Bev, don't try to use that cleverly in no conversation.
You mean try and use what cleverly? I can give you the Euclidean definition if you want.
He's giddy because he's got those other morons backing him.
That was a nervous laugh, that though. You know, that wasn't a normal. And
that was a girly laugh.
Yeah,
with all due respect to girls.
There's all three of them now, and they're sort of fighting off each other and trying to help each other out at the time, because they're like little girls where they want to help the friends and will come to the rescue at any time when their friend puts out the little warning whoop 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 that you come and save me. That's what they do.
Well yes, said, but bro. The Euclidean, the Euclidean definition only you are taking the idea that horizontal is always in the same orientation, and vertical is always in the same orientation, regardless of your position.
Yeah, they're perpendicular to each other, aren't they?
They're always perpendicular to one another, but what I consider to be vertical, you don't consider to be vertical.
Right, now, this is the bit. This is where they play the little game now, right? Because he's just said what you consider to be vertical, I don't consider to be vertical, or something like that. I try here.
Well, I don't understand what you mean. Hanging a plumb bob is what I would consider to be vertical.
Okay, so this is great.
Right, so I say when I hang a plumb bob, that was what I would consider to be vertical. What do you consider to be vertical? Because he just said we think they're both different things. And teams coming in to save it.
Hey, hold on, but you lead it. You're bringing me into the point I'm trying to make right here. You said I don't understand what you mean by one vertical for one person is not another vertical for another person. Are you sharing my screen now? Fight?
Yes. Yeah, you're live.
Yep.
Okay. Here are the measurements right here. Okay, these are the measurements between two people. Now, you can go through and do this. I'll share all the links. This is from the actual person who made the measurements. He documents the whole thing, so you can go back and read. But the key is right here in this table. Now, if you look, this is the zenith angle. This is a measurement from 1 to 7, and
he's just gonna go through.
He's doing tilt. He didn't even understand it.
He's doing Jeff's special tilt thing. He's obviously been told it from Jesse.
He has no idea what he's talking about.
Nope. He's never done surveying either, ever.
Nope.
Up to 180 degrees. That's just geometry.
Yeah,
1 degree per 69 miles. It's roughly 1 degree per 69 miles.
How do you measure the offset of a vertical?
This is I'm showing you right now.
What do you measure it from?
This is 1 degree, like an angle of slope for 69 miles. That makes no sense.
No, it's that's what happens at perspective drop, I reckon. Perspective compression, maybe.
Mm-hmm.
Within into that angle. I don't know. Over real life size, but I mean, we've gone from the bit where I was talking about the vertical because Tony was on his rant and I wanted to ask. Then Team said, and he's come back in again, and I'm still trying to get my point about the vertical. I just asked Team there about how would you measure the deviance from a vertical?
Your
This
plumb.
is what we're...
Your plumb. So, okay, this is exactly what we're saying. If it's flat, no matter what the orientation is, they should always equal 180 degrees. If it's convex, every single one of them is over 180 degrees. And then at the same time, it's not flat, and that it is spherical in nature and three-dimensional.
We'll just have to go over this one again, Cleary. Method that he's talking about. Imagine that they do the silly Jeff measurement thing they do where they supposedly measure parallel plumb lines.
Yeah, they're doing reciprocal leveling, and they're trying to make people think that they're measuring curvature because they're never specific about what they're doing.
Yeah.
Then you get people like this running around out here making a fool out of themselves.
Yeah,
representing something that was misrepresented to him.
Yeah, he's done some research by talking to Jesse Kozlowski. Jesse's told him this, how to do this measuring.
This is what they're taught, bro.
Yeah.
Can I just read a small little paragraph from Wikipedia?
Yeah.
Listen to this, Bev, and everybody. In astronomy, geography, and related sciences and contexts, a direction or plane passing by a given point is said to be a vertical if it contains the local gravity direction at that point. Did that make any sense to anybody?
Well, no.
That's the stuff they read. That's the stuff they're given.
Well, I'm guessing the only way you can check is with a plumb bob, right? That's vertical.
They even call vertical gravity now. That's ridiculous.
If the word gravity has to be in there for them, or else it just doesn't work, because they have to pretend that something could bend water around the ball. So vertical, horizontal, vertical to them means curved. It's as simple as that.
Horizontal, vertical's one of the straightest lines you can ever have.
Yeah,
if there's any straight lines, yeah.
It's incredible.
Yeah, but perpendicular is two straight lines.
Meeting at a 90 degree.
Yeah.
Yeah.
And if one of them is vertical.
How much longer have we got, Bev? You reckon on the video?
Not too long.
Wait, that's a good point, Bev. If they draw a vertical, right, and then a horizontal, are they only bending the horizontal?
Yeah, I think so. Yeah, that's why perpendicular is such a problem, because it's two straight lines.
What are they doing?
Yeah, they're not having a good time with this geometry. I'm telling you.
They can't draw a cross. They got to draw it with like bent wings.
Yeah, but then you see, you can't have all right angles being equal, because the ones at the bottom would obviously be less than the ones at the top, and it's not right. And of course, you can't measure an angle to a curve.
No, at least it's locally flat.
Yeah, about 15 minutes, Emma. Is that all right? I don't know how long whether it'll take. Maybe half an hour or so. It's not too long.
Gently, I need to ban him for this comment here.
May have gone live, that's all. What's Gently said?
Sorry, I didn't mean to talk over you. Ranty, I think, went live a minute ago. But yeah, Gently was just saying the horizontal and vertical are orientations to the ground, which is incidentally oriented to gravity.
Yeah.
They have to have that word gravity in.
Yeah.
Yeah, well, that's why I guess why our water level tested and horizontal straight line is such a problem. The best bit is yet to come. Don't leave just yet, because Septic's setting up Tony for a great one.
Geometry,
Go ahead,
right?
Tony, I'm sorry.
Team, you got
That's
a
it.
geometry.
So,
I'm better than you.
Bev,
Right, so he's just gone through all of that thing, and he won't. Now Tony's taking over and saving him again.
Bev.
So wait a minute. So
talking about
if
a plumb bob.
you have a perpendicular at the bottom of each of those lines,
He doesn't want me to talk. I think the instructions gone out. Shut Bev up.
if you have a perpendicular at the bottom of each of those lines, and you were to draw them perpendiculars out, they would intersect, right? I'm just
no.
Let Tony.
Let Tony speak. My God.
This is the PhD man. There we go. I have to do it again because this is good.
That was straight up rumpus.
Perpendicular at the bottom of each of those lines, and you were to draw them perpendiculars out, they would intersect, right? I'm just
no.
Let Tony say what.
This is too good, man. This is special.
Tony's got a PhD.
Wow, I want one too.
Let him talk.
You see his ability to use words and speak clearly.
He's obviously in the debate class as well when he was at university.
He's got to say it, and then you can respond. All right.
Okay, so Bev, if you drop a plumb bob from a string from your ceiling, and you draw a line through that, just a continuous line, okay, and I do the same thing here. I have a plumb bob hanging down from a string, and I draw a line straight through it. Your mental image is that those lines must be parallel, right?
Yeah, what's up with that?
Okay, they're not.
Oh,
yeah.
Well, they'd both be perpendicular
That's
to
the
a horizontal,
basic,
right?
They're perpendicular to different horizontals.
Mm-hmm.
So horizontal's different then.
For each person,
Does horizontal diverge from the horizontal?
Horizontal is different at different locations on Earth's surface.
Oh, really?
Right? And that's what we're... Yes, really.
I love this. Horizontal's different and verticals are different. You just can't tell because vertical's a plumb bob and horizontal is like a level.
Mm-hmm.
But it must be different because they live on a ball, right?
Yeah, well, he knows. He's telling you that they are because he lives on a ball.
He's about to find out a problem that he didn't realize before, and you can see it on his face. You ready? Here's the problem when you think this way, flippantly,
demonstrably.
Well, you want to demonstrable?
Uh-oh.
This is horizontal.
If you say then horizontal is horizontal on your model at the North Pole, would it be horizontal at the South Pole?
No. So
okay. So where would it?
He just got so used to saying no.
He's squinting again. He's having trouble.
Be horizontal.
So it's
just so we can get a frame of reference. Let's give us somewhere.
It's horizontal everywhere on the. It's horizontal everywhere.
Yeah, but in relation to being horizontal, you said it differs from horizontal, right?
So
right
at any point.
So is the horizontal at the North Pole the same as the horizontal at the equator, or could you call them two horizontals perpendicular to each other?
They're perpendicular to each other.
They'd be roughly perpendicular. Yeah.
Right. So Septic there leads him into that one.
Yeah.
They'd be perpendicular. Give him the right to go. Yeah, they'd be perpendicular. So horizontal, in case you aren't aware, Septic's just said it's all right for PhD Tony to say it. That horizontal is perpendicular to horizontal.
What?
Oh yeah. And you want it again? Look at him.
them two
No.
horizontals perpendicular to each other?
Oh yeah,
they're perpendicular to each other.
They'd be roughly perpendicular,
They are perpendicular. Yeah. So horizontal is
Roughly.
also perpendicular to horizontal.
The
At some
horizontal
points.
at one position. The horizontal at one position can be orthogonal to horizontal at another position. Yes.
Ooh, see the way he threw in orthogonal.
Orthogonal, yeah.
It's the same thing. It means the same thing, but
wow.
Nice.
Okay.
The two planes can be orthogonal.
Yeah. Whilst being perpendicular to vertical. So that means that every time you say horizontal is perpendicular to vertical, but you can also say vertical's perpendicular to vertical and horizontal is perpendicular to horizontal. That would also mean that horizontal is at 45 degrees to horizontal as well, right?
Yep.
Because all things go here with this now. So you don't really have a vertical and / horizontal frame of reference.
It's local. So vertical
how long
and
is
horizontal
local?
are defined locally.
Okay. So if I make
that local one, right? That's going to come back to haunt them.
Mm-hmm.
Rumpus
20
says
kilometers?
it's a point.
A singular point.
Local is a singular point that doesn't exist.
Without any magnitude, right?
Yeah.
But he said before we need 20 kilometers to see a curve, no?
Yeah. Yeah, you see the problem that these very, very clever people have with very, very basic geometry. It's a struggle.
Make a vertical, make a perpendicular, and then walk along that perpendicular. Can I drop another vertical onto it, and would that be perpendicular to the horizontal?
No.
He gave it a lot of thought about that as well. He watched his face. Look, his face is sort of his eyebrows come down about.
No, Scott.
Thinking. His eyes are up.
Vertical onto it, and would that be perpendicular to the horizontal?
No.
Oh. Oh, is that so? That's a one and one only vertical being perpendicular to horizontal rule, is it?
No.
Oh.
Doesn't sound very.
So you are allowed more perpendicular verticals to a horizontal.
At this point, you're spouting gibberish that is barely comprehensible.
He's lost it. He can't understand. He's not with it. He's losing it.
Welcome to my world.
Well,
Fight the Flat Earth, showing that he's always confused.
I'm like
this
I know that vertical and horizontal are perpendicular, right?
He's shouting.
All that body
Bev,
language.
I want to ask you a
right
question,
there,
okay? Do you understand what the difference between Euclidean and non-Euclidean is?
No, he doesn't.
One of them is Euclidean,
okay,
and
simple.
it's very well defined.
One of them is Euclidean and one of them is shite.
Basically, exactly.
I'm not trying
Geometry.
to be an ass here.
The other one isn't that.
Okay, that was the incorrect answer. I'll ask again.
Stupid.
Do you understand? Well, I mean, we interrupted him a little bit, so I'm going to let him get a chance to explain better. Can you tell me what the exact difference between Euclidean and non-Euclidean geometry is?
I quite like this.
Euclidean geometry is a very well-defined geometry system with axioms, definitions, and propositions. The other one isn't that.
You don't.
Isn't that?
Brilliant. It's just non. Like what Euclidean geometry is that? It's very well defined.
It's just like the non-zero error again.
You should have just sent fantasy. It's sheer La La Land, and then show him that circle where the man gets smaller as he goes to the edges. End of story.
Well, yeah, no, but that's different geometry. That is hyperbolic geometry, right? That's got a name. What these are playing here is they call it semantics. They say we use semantics, but what they're saying is, what's the difference between Euclidean geometry and non-Euclidean geometry? Or I'll phrase it another way. What's the difference between Euclidean geometry and not Euclidean geometry?
Yeah.
Like one of them is, and the other one isn't. It's that simple.
Gently says the other ones also have axiomatic with definitions.
The non-Euclidean one, does it? Or does it? You have to have a specific type of geometry. When you say non, you're just grouping things. Like Fight the Flat Earth's non-Euclidean geometry has straight lines defined as being curved lines.
Right.
And parallel lines intersecting within the geometry as well.
But isn't that like saying I'm going to solve a math problem by using non-math?
Yeah. Yeah, you just make up a different math. You're like that.
Yeah.
Not that math. No.
Not that math?
Not that math. No. We're just using the other math, not that one. They say, which one? Just not that one.
Not that one.
Yeah.
That's actually nonsense.
That's like saying, what's the difference between a rhinoceros and a chicken?
Right, so here goes. What's the difference between a rhinoceros and a chicken? Well, he's not that. He's just changed that, right? It's what's the difference between a rhinoceros and a not rhinoceros?
Yeah.
Isn't it? It should be.
Yeah, one's a rhinoceros and the other one is undefined.
Yeah, it's just not a rhinoceros. That's all you know about it.
Anti-rhinoceros, like an anti-particle.
A dark rhinoceros.
Yeah.
One's grey and the other.
No, one of them says non in front of it. What does that mean?
My God, not what you think of.
Just like.
Wait, no, I'm
just
sorry,
like
okay.
That was another little. Oh, do you see that as well? It's PhD Tony comes in with
one's
that.
grey and the other.
No, one of them says non in front of it.
Right, I say non because it says non. Listen to PhD Tony, debate expert.
What does that mean?
My God, not what you think of.
Just like.
Wait, no, I'm
just
sorry,
like
one sec. I literally have been working on the assumption that you were
nonce.
Oh,
that was nice of him, right? Yeah, because that has non in front of it.
So is he saying that they're not because they're called nonce? Oh, that makes no sense. No matter how you look at it.
Smarter than I thought, and I apologize for making that assumption because what you've just said shows that you are so dumb that I need to take you down an extra couple of levels.
Really well here.
Okay.
Gaslighting is not really
made up
question, because you're fucking crazy.
Bev, I want to ask you a question, a serious question. On a sphere, okay, what's the largest?
Here we go. This is one to remember. PhD.
Serious question. On a sphere, okay. What's the largest that we can make a triangle? And speaking of the summation of internal angles in non-Euclidean geometry on a sphere, what is the largest sum of the three internal angles that you can possibly have, and why?
Something like 270 degrees, something like that, is it? I don't know.
Nope.
That's just a guess.
Nope.
It's like 500.
Well, what do you think?
Okay, so if you were to take 3 points on the take 3 points on equidistant on the equator and draw a line between each one of them, that is essentially a triangle.
On the equator or on the sphere?
Right. He just made a mistake, and he sort of PhD Tony's going to fall into it. I'll give you it again. See whether you can get it or not, because it will need explaining to you. But see if anybody can get it.
Internal angles that you can possibly have, and why?
Something like 270 degrees, something like that, is it? I don't know.
Nope.
That's just a guess.
Nope.
Go on, what do you think?
Okay, so if you were to take 3 points on the take 3 points on equidistant on the equator and draw a line between each one of them, that is essentially
equidistant on the equator.
How is that possible? Yeah,
Is that
3
not a
points on the
straight line?
equator.
Well, here we go. Yeah, it's still it's building up, right? But that was a mistake because that's not how it works. I'll try and we'll get the camera out.
Triangle.
On the equator or on the sphere? What are you
540
talking about?
540
On the
degrees.
equator of a sphere.
Okay, that's what you can do. This is how they determine
Sorry?
things
Say
like
that again.
spherical excess. Say what again?
You can get a
So,
triangle.
imagine a
with
sphere.
540
Yes.
degrees. Did you say that?
Uh-huh.
Yes, a spherical
Yes,
triangle.
540 degrees, yes.
So imagine so you have a particular image of a triangle, and you need to just accept that a triangle is formed by 3 points on a surface. In this case, we're going to use a spherical surface. So imagine
Triangles, right?
Yes, and
just
there
quickly,
are three
question for the chat. Brian's logic.
He's just been interrupted. I don't think he liked that, and he was mid-flow. He was just explaining something that was very technical, and his brain was in gear then. Fight the flat Earth interrupted.
Yeah, he loses his train of thought really easily.
Yeah, I think so, but it wasn't doing very. I think he's getting upset.
Logic wants on 1 for yes, 2 for no. Carry on.
1.
So the yes, and you're this is basic. This is
geometry.
Your yes,
Listen
this
to
is
that.
basic geometry.
What was that?
Listen to that.
Yeah, because he's struggling, right? He's proper struggling.
This is basic. This is
geometry.
Your yes, this is basic geometry. This is basic geometry.
It is. Basic. Yes. What an angle
and
is.
You're demonstrating you have no
there
idea
are three
what
angles,
basic geometry is. Bev.
Each of which is 180 degrees. What's
Hear that?
Yeah.
I'll play it again, just in case anybody didn't hear that.
What's an angle
And
is.
you're demonstrating you have no
there
idea
are three
what
angles,
basic geometry is. Bev.
each of which is 180 degrees.
What's that?
3 angles, each 180 degrees.
Yep.
Oh.
Wow.
How good's that? Do you know how he's managed to do that?
I think in Star Trek when they play that 3D chess there, something like that.
Well, what did
Oh, I know what he did.
Yeah, go on.
Is he talking about the equator and a couple of longitude lines?
540 degrees is the biggest triangle available on the surface of a sphere. Yeah, Septic told him. 540. Do some maths.
That's a fancy triangle there.
Well, so there we go. I'm going to have to just come off here because this one definitely needs the video.
Would that be a non-Euclidean triangle, Bev?
Well, it's 540 degrees. I'm going to have to just set my camera up here for a second. How does he get to 180? That
Mathemagic.
Yeah. Well, how do you do it? Right, 540 degrees, and you're dealing with a.
You stretch out the lines. That's what you do.
So you do a maths thing where you go 540. There we go. We get screen on. You're right there. Emma, can you? Let's see if we can get this.
Yep, you are.
Yeah. Good with sound there as well, Michael.
Yep.
Right, so got 540, and we're going to divide it by 3. Anybody get an idea what number we come up with?
180.
Yeah.
180?
180. Now, we're going to get a triangle, right? So we're going to start off here, point A. Boom. Right? We're going to go with our line. Boom. And we get to point B. Now, anyone idea for the angle? What angle do we put on this end of this line of a triangle?
180.
Okay. Boom. There we go. We can go to point C. Now, point C.
Come on.
We've got a 180-degree angle.
Come on.
Okay. Now.
Is this a 4D triangle?
Well, I don't know. It's PhD Tony's 3D spherical triangle, but it doesn't seem to be any way of doing it, does there?
I don't know. Would angle C be a 360 or something? What the hell?
So here we go. Can you see this? Is that good? I should do it. Boom. Is that better?
Oh, that's good. Yeah.
Okay.
Yeah.
Right, so
that's cool.
you've got this here. This is the triangle. I'll do this for everyone. Is see that? This is the piece that we took out of here.
Yep.
And this is how you measure an angle, a square, and you do that there. So there's your angle on the straight sides, right? So you can't measure an angle on this curve, but this is where we go. Right now, you've got to imagine a point here, right? So this is one point of the triangle. We're going to draw a line and we're going to go down to the equator, right? That's line one, spherical triangle. We're then going to go all the way around the equator or the center point, right back to where we just met that other point, and then we're going to go back up to the top again.
What?
Right,
That's
so
ridiculous.
That is 580 degrees. So what you've got here is you've got a line that goes all the way around 360 degrees, and then you come down here, and you've got this one here is a 90, and then all the way back round another 90. So 2 90s and a 360. So basically, you've just chopped off the whole top of the sphere.
And
Now,
that's a triangle.
Well, it's a strange place you go to, right? When you go into spherical triangles and that 540 degree one.
Wow. Just when you thought you heard it all.
Yeah, that's...
Right, but PhD Tony, the very, very... didn't know that. That was the actual way you did the triangles. He thought he could do a quick mental thing and come up with not very thinking very much, a triangle that has 3 angles of 180 degrees. I'll have to put it on again because it is beautiful. How a PhD man can realize that a triangle with 3 180 degree lines and not realize that 180 degrees is a straight line. 3 straight line angles.
Demonstrating you have no idea
are 3
what
angles,
basic geometry is. Bev.
Each of which is 180 degrees. What's 3 times 180?
Look at how confident is he there? I actually break up laughing here when I realise. Sorry, an angle of 180 degrees.
Yes, we have 3 angles of 180 degrees.
That's a straight line, right?
Yes, except that in a
hold on.
Yes, but
180 is true, right? Yeah.
Hold on. Didn't you say on a spherical surface there is no straight lines? They're all bending. They're all curving.
Well, 180 degrees is a straight line,
Why are you
right?
contradicting yourself right now? Why are you contradicting yourself right now?
Well,
right.
He agreed.
Okay. Continue.
So, actually,
I was pointing out your contradiction, Bev. I'm sorry, Tony. Go ahead.
You will recall that I didn't
your
agree
angle.
with you.
Did he just say continue, and then interrupted him again immediately as he started going again, and then went, "Oh, sorry."
Bev. I'm sorry, Tony. Go ahead.
You will recall that I didn't agree
angle.
with you. You will recall that I actually tried to correct your two-dimensional thinking about the way angles are defined, but apparently without success. So, yeah, you understand that the universe is four-dimensional, right?
He's just gone from telling me that a triangle has 3 180-degree angles, and he's now going on to 4 dimensions.
Let's add time in there. What the heck?
What would they be?
At least four-dimensional.
Go
There'd be three spatial.
At least 4-dimensional.
There could be 15.
Maybe another one. Maybe another one. We don't know what it is yet.
Have him talk to
Maybe.
Kaku. He'll tell him.
Yeah,
There's like 13 of them.
Sure.
I know
time.
I know length, breadth, and thickness. I know them 3.
And time.
Time.
I knew it.
Right.
Right.
So are we living in are we in 4-dimensional space? Brenda said the other day that Euclidean geometry doesn't apply where gravity's involved.
Bev,
What
Brenda,
do you think of that?
Bev, Brenda isn't here, so we don't really worry about what Brenda was saying. Stick to the point.
See, they do that all the time, don't they?
That's what he's known for.
Yeah, we're not bothered about what Brenda says because Brenda says a load of shite. We're not talking about that. We're talking about
She's not here
Alan.
right now.
Yeah. I think I point out in a bit as well about Bob because he always brings up Bob and his 15-degree per hour drift or whatever. But I mean, he's never there to talk about it.
Well, you worry about what all the other people say, don't they? You put clips of them, don't you?
You're bringing up Brenda. Brenda isn't here. There's a PhD guy here answering your questions. Yeah. Maybe try and learn.
A PhD guy.
So
There's a PhD guy
who doesn't know what a freaking straight line is. Yeah, okay.
So Bob's not here either. But didn't you play a clip of him earlier?
Oh yeah, but that's freely available.
Yeah, well, that's Bob, isn't it? Like,
yeah. The Brenda video is freely available. She did it here.
So he's not here
to
defend himself. So why'd you bring him up?
Because he made the observation and posted it on Netflix for us
to use.
Brenda
said that. Well, I said the other day.
Yeah,
right.
Yeah.
Same thing.
Brenda hasn't done an experiment to demonstrate the Earth rotated. Has that happened?
God, he's got a headache or something.
He's trying to work out how to get a triangle with 180 degrees.
Bob did.
We are doing it.
Yeah.
Bob did. Bob
Sorry,
did,
I'm taking you away from geometry.
Bob did and posted it on Netflix, so we get to use it.
Okay.
So anyway, back to the questions. Brian has the link to join, by the way.
So
turn the dumpster fire up to 19.
So so three-dimensional reality has the potential to be more complicated than two-dimensional reality. Do you accept that?
Two-dimensional reality? You mean a plane surface?
So yes. So so geometrical principles that work for a plane are not necessarily the case on generalized surfaces in 3 dimensions.
Well, surveyors use Euclidean geometry, right? In all measurements. Like you use Euclidean geometry whenever you're doing Pythagoras or trigonometry, right?
It's rocking again.
Well, it's
depends on the
interesting that you
situation.
should bring that up. It depends.
Well, right
on the
angle
situation
triangles,
a little bit,
that's
but
definitely
yes.
Euclidean, right?
I would suggest that that's actually trigonometry. I would not call that Euclidean geometry.
Right angle triangle is within the definitions of Euclidean geometry. We did that the other day, Geometry 101, right?
a right-angled triangle was a specific type of triangle within Euclidean geometry, wasn't it?
Yeah, it's just hard to tell whether you're live or you're Memorex.
Yeah, let her stop it.
Yeah.
Yeah. I have that problem too.
And
based on a triangle of right angles and 180 degrees. That's definitely geometry, right?
I just want to introduce Brian, who has joined Brian's Logic. This is PhD Tony. He can teach you all about your questions. But let Bev finish his point, and then we get to you. Okay?
He can teach you all about your questions.
Yeah.
I like how it's
teach you
only
about
Tony.
your questions.
PhD Tony. Doesn't say his last name though.
We will find out.
Oh no, that'd be doxing.
Bob him. No, I'm kidding.
Yeah, no, we don't care about his surname at all.
We don't know, but somebody will find out, I'm sure.
We only care about the fact that he has a triangle with 3 180-degree angles. I mean, fantastic. We should get everybody to ask him that, like first question anytime you ever meet him.
Thanks for joining.
All right, Bray.
Hi.
All right, Bev, carry on with your point.
I don't know what the point was.
I would just when you say that trigonometry is a form of Euclidean geometry,
the triangle to sort of make geometry, right? The triangle.
Yeah, but there's different.
That's definitely geometry.
So if you what you describe as geometry and what I mean geometry are actually very different things.
Oh, do you not use Euclidean geometry?
I do, but I am not restricted to planar geometry. I can.
Euclidean
I have
has solid geometry, right?
Yes, Euclidean has solid geometry.
Yeah,
But if you have lines or curves on the surface of a non-flat solid, they don't obey the same geometrical relationships as they would if they were on a flat surface, right?
Yeah,
and I do want to point out that
balls,
listen,
yeah,
Bev, when you start talking about internal angles of triangles, you're literally talking about trigonometry, not geometry. So yeah, I think you are absolutely getting the two conflated. It can be unintentional. I'm not saying you're doing that to be like just.
Septic is just trying to muddy the waters and say that I'm conflating trigonometry with geometry, which I'm obviously not. Nobody's mentioned trigonometry or anything apart from your man here.
Honest or anything. I'm just saying I believe you're conflating geometry with trigonometry, whether it's intentional or unintentional. I don't know.
It's just a triangle, right? The trigonometry is based on the functions of a triangle and the sides and the angles, right?
Yep, that's right. But
yeah.
So a triangle is just a triangle on a generalized surface is the shape produced by any 3 points placed on that surface. Okay, and there will be connected by geodesics on that surface. And so you measure the angles between the geodesics connecting those points.
The geodesics are curved lines, so you can't really measure an angle between those curved lines. You have to have 2 straight lines in order to measure an angle. Never let anyone get away with saying that you can measure an angle to a curved line. It can't be done. Do you have a definition of an angle measured on a curved surface, right? Because I don't know.
God.
That they're always straight lines, right? This is the point I was making right at the very beginning.
They're
right,
geodesics. They're geodesics.
I do feel like that conversation has gone round in circles, and it has been answered several times already.
It should have been straight lines, though, shouldn't it?
The easiest way. No, the easiest way to understand it is that it is a continuous string. A geodesic is a continuous string of infinitely small straight lines.
Do you hear that?
It's an infinite line.
Yeah.
Here we go again. This is septic. I mean, like,
That
remember,
is so
septic
stupid.
doesn't know anything about anything and doesn't have any degrees. He's had a word with Jesse Kozlowski. Maybe Jesse told him this. Listen to this again.
And it has been answered several times
Yeah,
already.
it should have been straight lines, though, shouldn't it?
The easiest
Not
way.
circles. That's the point.
No, the easiest way to understand it is that it is a continuous string. A geodesic is a continuous string of infinitely small straight lines. Okay, so when it's following a geodesic, it is literally a small set of continuously straight lines that are going around a curved surface. So
how can you have a continuously set of straight lines? So I mean, he's right. It's a tilt. There's no curve. Straight lines. It's the tilt. So I mean, I presume he has been talking to Jesse, and Jesse must have said to him, "Look, septic, there's no such thing as curve. There's only tilt, because it's all straight lines." It just happens to be that they're all straight lines are horizontal on a plane, and they just imagine a curve.
That's right.
So at the point where you're measuring the angle, no, it is not. It's fucking calculus. Okay, I can understand that it's fucking hard for you to understand, but it's fucking calculus, so you need to understand that.
All three of you.
Okay, so
Bendy straight
it's
lines.
not our fault. It is not
crazy.
our fault that you don't understand.
How
It's
do you
not our fault that you don't
differentiate
fucking
between
understand.
a straight line and a
Dude,
curved
it
line?
is not.
That's it.
Just an angry troll now.
Done. Yeah. Absolutely ridiculous.
A straight line bends because they told us it does, and that's just it. You have to accept it.
Yeah, you just don't understand. If you don't understand that straight lines curve, then you must
you're
be
insane.
Yeah. Yeah. So thanks for listening. I hope you had fun.
Yeah, that was the awesome PhD Tony.
Yeah, PhD time. I'm curious. I want the rematch, or for him to come back again, because fascinating chatting with Tony. It'd be much better if he didn't get interrupted.
Yes.
By.
I don't think he's going to come back around.
But
that'd be fun if he did.
He'd be brave. I mean, he'd be a lot braver than all of the other ones. People that are running away from us.
Yeah, they're all running scared, man. This is a dangerous topic, you know. Vertical is perpendicular to horizontal. Level is horizontal. You know, it's very dangerous. They don't want any part of it. They're all hiding now. All these fake surveyors are in hiding all of a sudden. They're not doing anything anymore. They won't come and address any of the issues that we brought up. They're just silent. What's going on with that?
Yeah. I'm just scared, as far as I can see. I mean, they say they're not, but I mean, it is becoming pretty obvious that these people, for one reason or another, I don't, presuming that they just, they have no answer to it. That's what I think it is. And so they're not going to come and talk to us. But I mean, we're here. We're inviting the conversation. We're inviting anybody to come and talk, anybody to come and have a look about what we're doing when we do our tests of a weekend.
Yeah.
Come and get involved and come and have a chat. I mean, there's nothing to hide.
Here's just a word of advice for you, Globeheads. If you want to stay relevant, you need to come in here and address some of these issues. Otherwise, you're irrelevant, and you know you're not even in this topic anymore if you can't address these basic geometric issues.
Oh, and one more thing before we go. I just have to say, sorry, Kosho.
Not you, Nathan.
No, I just have to apologize to Kosho. Sorry, Kosho. But yeah, on that note, thanks everyone for watching. And we'll see you again soon. Take care.
Peace.
Thank you, Emma.